Hi guys, I'm Satya here and I'm presenting this Android interview questions in behalf of Edureka. I've been with Edureka for a while and I do train on Android programs, AAD, Google certified Android programs. And this happens to be the most sought after the subject in the IT. And the Google has promised about 3 million jobs down the line. That's about the next 2 years. Now, guys, I have about 2 decades of experience in IT, and I started off with telecommunications, and then I moved on to Symbian. I was there for about 5 years in Symbian, and then I moved on to Android. And I've been with Android right from the day the Android has started, and I've been growing with Android. All right, so all of you want the job, and all of you are curious to know what would be the interview and what is that I'm going to be grilled with and what is that I have in shelf. Now in this session we're going to completely cover the Android right from the first chapter to the last chapter, that what we normally conduct in Edureka. And here I'm going to I'll be walking you through the various questions that what you're going to face in your interviews and how to answer it. And if you really want to go deep into it, and in fact, I'll be highlighting all those places, and definitely Edureka is offering you a beautiful course, and that is what you call it as the AAD program. And after that, you can take up the Google examinations. Then Google examinations is something that it is going to put you all in limelight. And as of now, if you take the Google examinations, you'll be the first person out of, you'll be 1 out of 100 guy. And you still have a lot of reward and you have a lot of opportunities and the world is looking at you. All right, guys, let us start off with the interview questions. So let us go and see what exactly the Android has it on shelf for us. Now, let us take a look at this market and the salary trends. Normally, we all are interested in what kind of a market is it and what exactly is happening in the market and what is the kind of salary that we all will get. Now, we have some information for you from Gartner. And those guys, the Gartner, that what you all see here at the bottom right corner of the screen, and these are the guys that in fact, they keep upgrading the information about the IT industry, and they will give you 100% accurate information about the IT industry, and you can trust them 100%. Now here, as you all can see, in a nutshell, you can very easily understand we have different operating systems just under the header operating system. We have Android, iOS, others, and total. Now, if you look into Android, the market share is about 86.1%, and iOS is 13.7%. Though the iPhone is fancy and people, they really want to have the iPhone, but the Android has taken over the iPhone and we are in 86.1%. The other phones is taking up the share of 0.2, that sums up to 100%. So obviously the Android is doing really good in the market, and most of the phone, this is almost touching about 90%. Most of the phone that what people are using today is Android, and a lot of research is on and a lot of new stuff is coming into Android. Google is bringing mind-blowing characteristics and features into Android, and you're going to be one of those to be with. No, you're going to be with a bandwagon, and you'll be celebrating with Google when you take up this examinations and courses and all that. So let's get going with this, and this is just to get you an information of where exactly you stand and what exactly is Android and what kind of percentage it is holding in the market. And as I told you, Google has promised about 3 billion jobs in the next 2 years, and that is what it is, and almost everyone will get the job, and that is where the industry is heading towards. Now, all of you would be interested with the salary trends, and in Android, you can expect about 2,83,566 per annum, all right? Now, let me share my experience with you. This is not just that. I've got a guy working for the IT, and he is working on Android and NDK and all that stuff, and he has got about 3 to 4 years of experience, and he is getting this 2,83,566 monthly, not per annum, and he is getting it for 1 month. So guys, please, it depends on the qualities and characteristics that what you hold by end of the day, and that is what determines your standard and your salary. So there is no dearth to it, and this is a ballpark figure that what has been stated. here, as well as in India, as well as in US. In US, it is 117,564 per annum, and this is what it fetches you in US. And this is just a ballpark figure, and the source is Indeed.com, and you can make much better than what has been stated here. Now comes the most awaited stuff of this particular day is the interview questions. Now guys, it's fairly simple. Now it's just about how much of passion that you have towards Android and how much are you in love with Android and what is that you really want to do. Don't worry about the job. And if you are looking at it with a passion, if you are looking at it with a love, and if you say, yes, I know all this stuff, I know little more than this, then 100% you have a job on hand and you need not even have to think about it. Now the question arises, what is Android? Now you guys, I just want to make it very brief. I don't want to tell you the story of who founded Android and how Google took over Android, and that is not the concept that what we are looking at. We are jumping straight into the stuff. Now, as you all can see, a couple of points. Now here, Android, initially it was not the operating system. Slowly it evolved as an operating system. And this operating system is even more powerful than Windows and compared to any of the other operating system. Because this is almost like writing a kind of assembly language program in a very less memory, in a very less space that you have to write an amazing and a beautiful program. And that is what it is all about. And that is where the operating system predominantly came into the picture, and they got in the Android activity stack and framework and so on and so forth. And that's how the Android became an operating system by end of the day. And by the time that they brought Android as an operating system, earlier they were using a generic editor and IDE called as Eclipse. Now the Google disowned Eclipse, that's about 2 years ago, and they brought in Android Studio, and that makes everything complete. Now, the phone is predominantly been designed for touchscreen, okay? And most of the phone, earlier days, we used to think about the keypads and touchscreen. Now, today, as of today, almost every phone that you buy in the market, let it be the cheap phone or let it be an expensive one, it all has the touchscreen. Now, the other important point that what you have to look at is the Android is open source. Now, there are two ways of installing Android. Normally, the way that you install Android, that is a limited version that what you're trying to install. Now, you can install Android open source, that is the complete source code is available for you and it is at your perusal, and you can dig into it and you can study how exactly everything is working. And the complete source, the Android source is open and you all have it at your fingertips. And if you want to do anything creative more than what Android is already doing, and we can take up the open source and we can start rigging up your codes into it, right? And the complete code is being written in Java, and most of us, we jump into Java because Java is very user-friendly and very simple and a very interesting language, and we all move on to Java, and Android is having Java as the base. So you need not have to learn 100% of Java. Even if you know the core Java, that's about 40% of Java, and you're good to go with Android, and it has all been written in Java. Now, if you try to look at what exactly lies underneath, now the complete Android framework is based upon the LTS, that is Linux kernel long-term support. Now, all the code has been scooped from the Linux. Now, don't get excited. Wow, it is going to be the process, it is going to be the memory, it is going to be the threads and so on and so forth. Now, what they have done, they have scooped up everything from Linux and they have remodeled the process, the memory, and everything to the way the Android looks at, meaning they have to make it very concise, right? So they've been using what exactly Android needs, only that they've been scooped and they've modified and they're using it in the applications. So this is what it is all about, Android, and this is how it goes. Now let us try to look at the features of Android. Now you all, even a kid knows most of it, right? So we have the user interface. Now here you have the UI and UX, and normally most of you, when you're working on Android, you guys are going to work on the UI, that is the user interface. And now you have the messaging architecture which has been brought into Android, and you have got the various sources of messaging. It has been brought into Android. We have the web browsers. Now, web browsers are the regular browsers that what you normally see in your Java, even that has been brought into Android. So when you guys look at the web browsers, those are not the native Android code. It has been plugged from the Java. And normally when you write the Android applications, we all start looking at the code as the native code. And normally when you come to the web browsers, and we normally say a big no to it because it consumes up a lot of memory, a lot of space, and it is a bit sluggish. So we really don't recommend for an Android program to use the web browsers, and we have many different ways of avoiding this and writing the native applications. Now when it comes to the connectivity, this diagram reminds you what kind of connectivity your phone can have. Now you have the Bluetooth, you have USB, you have Wi-Fi, you have Wi-Fi direct, and these are the basic connectivities that what we can talk about, right? Then we have the multi-touch. Now you guys would have played the game that instead of just touching on one place, you can touch on 2, 3 areas, and your phone can identify the multi-touch, and it has got the multitasking. Now do not ask me, is that a process or what is it? What exactly is the multitasking and how it is working? Now, Android in turn has a lot of threads working, and Android in turn has got something called as the services, and services constantly, it works like a process in the background memory, and that is where the Android stands for the multitasking. Multitasking, the Android has the time slicing concept also in threads, and Android has services too. The services in turn will be running all the time in the background. So that's how it got the name of multitasking here. And multi-language. Now when you guys write an application just for India, that will not really work. Now you may want to, the people may want to write, they may want to buy the product, your application in Japan, in China, and in France. So they expect their language, their native language. And the Android supports the locale that is called as the multi-language. You can set it up with any language that the user wants. Or if you want to create your own new language, yes, the Android will also allow you to create a new language, and you can even bring it up into your phone. Then when it comes to storage, now Android, obviously, as you all can see, the first thing that what you all can see is what is my RAM size and what is my SD card size and so on and so forth. So obviously the SD card happens to be the storage. Now we have two kinds of storage. One is the internal storage, and the other one is the external storage. The external storage happens to be the SD card. The internal storage happens to be the phone memory. So apart from that, we have got shared preferences, we have got SQLite as what is available for to call it as storage, and this 4 concludes your storage. There is your internal memory, and there is SD card, shared preferences, and your SQLite. All that put together, you can call it as storage. Now we have Android Beam. This is nothing but your near phone communications. There is the NFC, and Android supports the NFC, and in fact NFC also is taking up a lot of new turns and twists, and they're making it more efficient, and they're trying to bring in a lot more stuff via the NFC, and that is what you call it as the Android Beam. Now let's get to the architecture. Now whatever that we have seen so far is very frivolous, and those things are very obvious that what exactly the Android is, and when you go for the serious interviews, people are really not interested in whatever you have looked at so far. Now let us get to the thick of it, and let us try to understand what exactly is the Android architecture. Now guys, this is the diagram that what you all have looked into. Now, it is just not the diagram. It is just not the punishment that what you're going to go through. Now, this in turn will decide what you are going to be by end of the day, whether you're going to be the UI designer, whether you're going to be the Android application level programmer, or will you be writing the NDK applications. This green block that what you all see here, the libraries, it's all been written via the NDK. Or if you have the urge to be a device driver programmer, or if you have the urge to do anything onto the board, you're right here at the Linux kernel. And now you can opt for any of these verticals. It can be application, it can be your NDK, or it can be the driver, or you can be a hardware guy who's sitting on top of this board. Now, this is what Android is out to offer you. Now, let us look into this diagram in a very simple way. I don't want to complicate this stuff. In fact, I can go on talking about it for half an hour and I can tell you what exactly it's all about. Let me tell you the complete story in about 2 minutes. Now, normally, when we take up the stack diagram, we come from the bottom. So normally when you write applications, you're sitting there here at the application level. So let us try to understand this diagram right from the bottom. Now, any of the companies, let me take any of the healthcare companies, and if they want to use the Android into their devices, they convert the phone into the healthcare devices and they take up the Linux, whatever is available in Android. So whatever else that they want, they scoop from Linux, they recompile the complete Linux and they will try to put it onto the device of what they're using. Now, that is how they mount the Linux onto their devices. Just by doing so, you're bringing in the display driver, you're bringing in the camera, you're bringing in the memory of how it has to work, and you're bringing in the most important thing is the inter-process communications. Now, this inter-process communication is something that it lets two different applications to talk. Now, as you all have understood that Android in turn works on a sandbox. Every application works on the sandbox. Now, if you want to start communicating between two different applications, then you have to bring in the IPCs and AADLs and all that, and then the binders and so on and so forth into the picture. And that is where the IPCs is going to come in. And then comes the power management. Now, the power management has been treated as the most important component in Android. Now, whenever you write your application, it is based on the time and space complexity. The more your time you take, the more your space you take, obviously the more the power you take. So how exactly to reduce the power and how exactly to bring in the schedulers, how to bring in the job schedulers, and how to have your program tagged along to the power management, to the job schedulers, and how to execute all that they have been working on with the power management. And this happens to be the most interesting part of your complete framework, and people are doing a lot of research on day-to-day basis. Then we have the audio drivers, and whenever you listen to a song, now MP3, MP4 and all that, and those are called as the codecs. And now this drivers has been installed here at the hardware level, and the library in turn will start using the codecs, and the library in turn will start spooling. It will start pulling the data from your codec and it will play the songs, the audio or video or whatever. So the library can stream and it can spool, it can do all such things with this audio drivers. Now we have the Wi-Fi driver, we have the camera driver and so on and so forth. Now let us hold on to one of the drivers, that is a camera driver, and I'll be talking more about it to relate the other blocks and how exactly it is being linked. Now, whatever you have seen here, it is all about the device drivers and it is all about the hardware. Now, when it comes to the library, now we have the library files that is normally called as .so files, .so files or the library files, and we have the Surface Manager. Now, when you want to display an image or when you want to play a video, it happens to be on top of the Surface Manager. And when you want to record a video, obviously you'll be using the OpenGL. Now this OpenGL, you have to have your 3D this thing in it in your phone, and without which the OpenGL will not work, right? So the camera in turn is going to use the OpenGL. The OpenGL in turn will allow you to have all the 3D recordings and so on and so forth. And even this 3D chipset is a must for you to have it on your phone to use the OpenGL. And when you come to this SSL, and it is all about the 2D that what you're looking at. And also you guys can see the WebKit. This in turn will help you to run your Chrome and your Safari and all such things using this WebKit. SQLite, predominantly all of you know, this in turn will carry the complete SQLite database, and that happens to be a part of your Android framework. Now, we do have the runtime. Now, in fact, we are going to go deeper into the runtime as we start moving into this interview questions. There, I'll be talking about the core libraries. I'll be talking more about the Dalvik virtual machine. Guys, please hang on as we start going further down. I'll be talking more about the Dalvik virtual machines. Now comes the application framework, and these guys are the managers without which you cannot write an APK, you cannot write an Android application. Now, if at all, if your application has to work, the application framework manager has to be active. Now, for example, if you receive a call that is happening at the low level, that is happening at the Linux kernel, and you have to receive your IR, and then somebody has to go up all the way to the application and say that you have a call. Now, when there's a call, the library in turn will spool the information that there's a call. It tells the telephony manager that there's a call. Telephony manager in turn will penetrate through the application layer, and it tells that, hey guys, you have a call, take it. And you'll be receiving the call. And when the call is done, and when you're done with the call, you're going to talk back to the telephony manager, and this in turn will go to, with the help of the library, and it'll go to the Linux kernel. Now guys, between the library and Linux kernel, you also see a layer called as the hardware abstraction layer that stays in form of the glue to communicate between the driver and the library. All right, so that's how the communications will take place. Now, for example, being in the application level, you want to take a photograph, and you just press on the click button on the camera, which happens to be your software. Now at that point of time, now the framework manager in turn will get to understand what exactly that you want to do, and it carries the information all the way to the library, and from the library it carries the information all the way to the camera driver, and it says, hey, somebody has clicked on the button, why don't you take a picture? And that is how, right from the application level, you come to the framework, you come to the libraries, and then you talk to the camera. Very similarly, you're here, the managers that what you can see here is the activity manager. Activity manager is a manager which in turn keeps track of all the applications. All the applications will come under the activity manager to know which application is working and the life cycle and so on and so forth. And we have the Windows manager that in turn will take care of your screen, the rectangle, and your applications, the UI and so on and so forth. We have the content providers. This in turn will help to share the data from your sandbox to the other applications. And we have the package manager. Package manager is the guy who keeps track of all the running applications in your emulator or in your phone. Now, who has to know about it? The package manager will know how many applications are running, how many applications are suspended, how many applications has got permissions to it, and so on and so forth. A lot of information has been tracked by the package manager. All right, without package manager, your applications cannot work. Now, as I told you briefly, the telephony manager in turn will tell you what call is coming in, what is the number, from which tower the call is coming, and the durations and so on and so forth. Everything is being taken care of, and the network speed, all that is being taken care of by the telephony manager. So as your resource manager, location manager, and notification manager. Location manager, now predominantly the Google Maps that when you all look at it, and that deals with the location manager. All right, guys, so that is how all the managers, and it is just not this managers, you got a lot more managers which has been rigged into the Android framework, and this managers constantly, they create a wrapper on top of the application, and they monitor the application, and they keep helping the application with the right resources. So that is how your application works at this particular layer, that is at the application level. All right, so this is at a very high level. Now, you guys, when you sign up for the Android course, and most of you will be sitting up here at the application layer, and you'll be writing the program. Now, when you sign up for a course on NDK, that is a native development kit, and that happens to be the C and C++ program, and you guys will be sitting here in this green box, and you'll be writing your program, and that in turn will have a close relationship with the hardware and with the Linux kernel. And then you guys will be connecting your application through the application framework, and that's how the application will get connected and to your main applications. Now, this is what exactly happens with your architecture, and normally this we call it as the framework also. All right, so that's about your Android architecture, and you can call it as framework, or this can be called as the Android stack also. All right. Now comes the various versions in Android. Now, Android, they have been bent upon the name of the desserts. Now, instead of calling it as, regularly we call it as a version 11, 12, 13, so on and so forth, they call all the versions by the name of the dessert, like the donut. So here you all can see how it has been written. Now you all can see this 1.0 and 1.1, and that is the second one is pointing to 1.1, and the third one is pointing to the cupcake, and fourth one is pointing to the donut, and fifth is to the eclair, sixth is to the frio, and 7 is gingerbread, and 8 is honeycomb. Guys, I just skimmed through everything. I didn't even talk about it because as of now, till 8, the phones are not existing. If at all, if it is existing, the old iconic phones, and that is less than 1% of the phones. So nobody wants to write the application who's going to buy for less than 1%. So we are really not interested in writing any applications till honeycomb. When you take up the ice cream sandwich, and when you normally they start from jelly bean and Kit Kat. Yeah, even this ice cream sandwich also is welcome, and you can start writing applications from 4.0. There is ice cream sandwich, jelly bean, and so on. Now, ice cream sandwich, jelly bean, Kit Kat, lollipop. Now, this 4 version, as of now, is the major versions, and a lot of people they're using. More than 75% of the industry of the users, they're depending on ice cream sandwich, jelly bean, lollipop, and Kit Kat. And so many of them, they're using these versions as of now. And if you say that, hey, I'm getting excited, let me go to Nugget, let me go to O. Now, less than 1%, they're using the Nugget and O. So stick to this, and this is how the versioning will work. And when you, since you all have the experience of writing applications, and you would have seen at the compilation time when you click on lollipop for compiling, and you would have seen how many % of the users are there to work on it. Now, as you all can see, we have various versions. Now, from ice cream sandwich to jelly bean, it is 4.0 to 4.1, and from 4.1 to 4.4 is your Kit Kat. Now, whenever they change the version, obviously the hardware too will change. Now, the new hardware will be released into the market. And obviously, when the new hardware is released into the market, when you're writing a software, when you're using the Lollipop API, now it is not downward compatible. We cannot take it onto Honeycomb, or we cannot think about Frio to execute your applications there, because it is completely dependent on hardware, and that is what you guys have to look at. And that's about your various versions of Android. Now, if you take Marshmallow, if you take Nugget, it is still buggy. So not many people have put their hands as of now into Nugget. It may take a while to have the perfect version. Now comes an activity. What exactly is an activity? Now, normally, when you guys write an application in Android, the extension is called as APK. The file extension is called as an APK, and it is also called as, your application is also called as an activity. Now let us take a look at the activity. What exactly is activity? Now guys, as I go on explaining, do not come to the conclusion that I'm only talking and I'm reading the slides out for you. Now, I'll be taking you right into the Android Studio to experience a couple of things. And whenever you see it in Android Studio, it stays in your mind forever. So I'll be taking you into the code, and I'll be showing you the code, and I'll also be explaining you what exactly it is and what it means to you. Now, when you all see the screen, you all can see this. This looks more like an application for you. Now, there are 2 important things. It has been rigged into this particular screen. Now, let us take a look. What exactly is that? Now, an activity is the window representation of any application in Android. Now, you see a beautiful screen, right? Now, the question is this a UI or is it an activity? Is what would be the first question. Now, my answer is whatever you're seeing here is normally called as the UI. Now, whatever you're seeing beneath this, whatever that cannot be seen, is what you call it as an activity, and UI is sitting on top of the activity. The activity is the core application that in turn is going to render the information from here to the server and so on, so forth. Now here, as we saw, activity is a window representation of an application in Android. It serves as an entry point for user interaction. The user they have to say something. So the activity takes it, and meaning the UI takes it and it gives it to the activity to perform the action, to do whatever it has to do with your username and password. Now each activity has a layout file where you can place your UI. Now whenever we talk about the activity, whenever you guys create an activity, now you all would have seen activity main underscore XML or main underscore activity dot XML. That XML happens to be the UI. Now every activity that you create has an XML, and in your XML you can design the screen so that it becomes the UI and activity will become one. Now, when you have an application, when you create a project, you can create as many activities you want. But guys, do remember, when you have about 10 activities in your application, one activity happens to be the launcher activity. The rest of it happens to be the default activities. Meaning, when in Java, you write public static main, isn't it? That is a program, it's called as a launching program. And in Android, you will have a launcher too. When you go to the manifest.xml, you guys, in fact, I'll be showing you that also down the line. And that is where you guys can see .main in the action and .launcher in your category. And that application will be the launcher. The other 9 applications will be the default activity, meaning that those activities in turn is going to help the launcher in profiling a lot of informations to it. Now, let us take a brief look about the activity and what exactly is the UI and an activity. Let me go to my studio. Now, for that, I have to just minimize this for a while, and I'm right there in the studio. Don't worry about the code. Now we are trying to understand what exactly is an activity. Now you all can see that you created a class called as a main activity here, and this is the main activity. While creating the project, now you would have seen the main activity and activity main.xml both came automatically for you. Now activity main.xml is where you have the UI. This is the user interface. Guys, this is how the first application screen will look like, and this is what is your UI. The UI sits on top of this main activity. If you ask me how, it's very simple. Now you need not have to worry about these lines. Now I can put entire thing in a remark. You need not have to worry about it. Now all that you see here is set content view. Now to set content view, you're calling resource. That means you're coming here to resource, and you called layout, and you came here to the layout, and you gave the name activity main. Now this is the file name. So however the file has to be shown, has to be represented, that will be represented by the set content view. Now what exactly is that you're trying to see here is we are bringing in the view, or I can say UI in our activity. Now this is what it is, and this is where you all have seen the activity, and you all can see your UI. Now as I told you that you can have many activities, you know what I'm doing? I'm just going to new, and let me create one more activity that let me call that as the blank activity, that is the empty activity. Let me click on this. Now other activity. I'm just going to call it as other activity. Now you all can see the layout name. The layout name is the activity other. Now this is the UI for the other activity that what I have created. Let me say finished. Now I created, now you all can see 2 activities. Now I told you one activity is the launcher activity, and all the other activities happens to be the default activity. And also the main activity is being related with your activity main. Now let me click on this. It says hello world. Now other activity, now let me go to this hello world, to the text, and all you can do is just copy this right here in your other activity. Now instead of hello world, let me call this as activity. Now this is the screen that what you guys are designing, and when I click on this, it says the other activity. Now the other activity is related to the other activity. As you all can see, it is a set content view, and the content you all can see is the other activity. It holds the other activity. Now the other activity happens to be the default activity. As I told you, let us go to the manifest quickly and see what it is. Now the first activity is the main activity that you all can see here, and I told you the action area, you can see the main here at the end. Now the category that is called as the launcher, at the end you all can see the launcher. Now the launching, when you have your project with about 20 different activities, now you may want to know who is the launcher. So just come to the manifest and you can check the activity, whichever the activity has got the main and launcher, and this is the launching activity. You can come to a conclusion. Now getting back to the other activity, now it's fairly simple. Now this guys will not have, you will have the intent filter. You can bring in an intent filter here, and here I can say dot other activity. Now here I can say dot default, right? So I can bring in the default here. So that is how you can have all the other activities. You'll see the activity name and action, and you'll get to see something called as the default. So these activities are not the launching applications. So just to keep it simple, now when you don't see anything here, now by default it is called as the default activity. The any other activity that what the compiler is going to, what your Android IDE is going to create, everything is going to be the default activities by default. Now the other activity is the default activity. Guys, please do remember this, and that is how it happens. Let me move on to my slide. Now we saw an activity is a window representation of any application in Android. It serves as an entry point for the user interaction. Now because you have to give the username and password, each activity has a layout file where you can place your UI. Right now I've shown you what exactly is UI and how the UI can be brought on top of your application. An application can have different activities. I've shown you how many default activities that what you can have in your applications. So that's about your activity. Now comes the most interesting and the important aspect of the Android, that happens to be the activity life cycle. Now you have to understand something here. Whatever the applications that you have copied into in your phone, all the applications are working, or few of the applications would have killed because the Android does not have much of resource, so it would have deleted few of your applications. Now you don't have anything called as an execute, or you don't have anything called as an delete. Now after installing, all the applications will live in your phone. That is something that what you have to remember, and I'm going to build upon this as we start progressing further down. Now when you start looking at the activity lifecycle, now you click on your application. Let me say that you're clicking on the gallery. Now the activity is launched, meaning you would have copied, you would have compiled it, and you would have launched your gallery application onto the emulator or onto the phone. Now the very minute the gallery application is going to come up, meaning you're starting your application, it calls the function called as onCreate. This happens to be a kind of constructor for your Android applications. Now when I say constructor, what rings in your mind is the constructors cannot be called repeatedly. The constructor will be called only once when the object is coming into the scope. And that is what exactly happens in your activity. When the activity is coming up for the first time, the constructor is getting called. Then comes to onStart. Now this after onCreate, the control will come to onStart, wherein your activity is getting ready to start. Now as of now, I don't want to talk more about it. I'll come back and I will tell you the meaning of onStart in a minute from now. Now the control comes to onCreate, it goes to onStart, and it goes to onResume, right? Now you'll be curious to know what exactly is resume. I'm going to come to it. Now comes the activity, and it is running. Your activity is running. Now guys, what you did, you clicked on the gallery. Now the gallery is running. Now I did not talk about the start and resume, and it is in suspense, and I'm going to come back to it. Now the activity is running as of now. Now imagine a call is going to come in. Now the call has the highest priority in your phone, right? Now, when the call is coming in, you cannot hold on to the gallery. The gallery will go away and you have to take the call. At that point of time, the gallery that what you have been working on will go to on pause mode. Whenever other application comes up on top of the stack, that means when it is springing up, when it is coming up, or you would have gone and clicked on WhatsApp, or you would have gone and clicked on Facebook. Now at that point of time, the gallery will go in the background. Not only the call, it can be any of the other application. The gallery will go into the background. That means it is going to say on pause, right? The application is going into the pause mode. Now, when the application is going into the pause mode, guys, do remember the activities that what you're trying to run, you're running the activity with the space, with the time and space complexity, and you have a lot of problem with the memory, and you don't have, the Android does not have too much of memory to give to all the applications generously. So at that point of time, all the variables that what is being related to the activity, that what has been running at that point of time, and it is going to get quelled, it is going to get destroyed. So to avoid that, the very minute the control comes to on pause, it becomes your job to store the value into the shared preferences or into any of the local variables. And that is what you guys will be doing in on pause. All right. Now, when you want to resume, now after pause, you want to resume. Now, how this can happen? Now, let me say on top of your activity, a dialog box came in. Dialog box is not a complete proper application. No, momentarily a dialog box is coming, and at that point of time, your application can go to on pause. And when the dialog box goes away from your application, the control can go to on resume and your application can resume. And this is where I told you, I'll come back to it. Now, in such situations, the dialog box is away and you're going to come to resume and you're going to start your work. And that is a momentary disturbance that what you have noticed. Now, a call is coming in. Now, when a call comes in, the control will go to on pause. That means your application has to be paused. And eventually your application also should be stopped. The very minute you all can see the stop here, that means you're going to lose all the data that which has been held with the variables in your application. That is what exactly is going to happen when it comes to on stop. Now, you guys can prepare yourself an on pause or an on stop to store, to save all the variables in shared preferences or with your local variables. Then comes to on restart. That means when your application, when you're done with the call, the control will come to restart and the control will go to start. Now, when the control goes to start, now it is your option to bring all the values back in your on start. Now, let me say in on create, you guys are going to declare variable like integer I is equal to 0, k is equal to 0. While starting, you wanted those variables to start from 10. Say I is equal to 10 and k is equal to 10. So whenever your application comes to the start mode, you want to start from that. And that is what is going to happen here. And it retrieves or whatever the value that you would have stored and in your shared preferences, and you'll be retrieving it here in on start. And on start and it comes to on resume, and again your activity will start running because you gave all the values back to it so that you will not feel the activity lost the control, the activity is almost about to die and it came back into action. All those things you cannot make out here, but literally that is the scenario that what you have gone through right here. Now, when the apps with higher priority needs memory, now your application has gone to the stop mode, meaning you've been watching the gallery. After that, you clicked on Facebook, then you moved on to WhatsApp, then you moved on to so many other applications, you forgot the gallery itself. After that, for a week, you don't even remember the gallery. You don't care for it because somebody said, hey, this picture is good and you watched it, and after that, you don't care for it. So that gallery has been there in your memory for a week, and then the Android realizes that this application has not been used for a while. Now, at that point of time, the Android in turn will clear the resources. Now, that is when the app process will get killed. That means your gallery is no more. It is dead. Now, then the user navigates to the on create activity. That means the gallery is gone and you're off to creating a new program. Whenever the new program is coming up, obviously you guys are in your on create. All right, guys. So this is how And this is what it is all about, the life cycle of your application. Let us go quickly take a look how this works. Now we do have the last interesting stuff that happens to be on destroy. Now whenever you guys click on the back button, now the back button meaning you don't want that application. That's what you mean. When you say I don't want the application, you're disowning the application. That is when the on destroy gets called. Now when the on destroy gets called, now if you want to bring back your application all over again, going and clicking on your icon, now your application has to start all over again from on create. When the application is dead, it has to start from the beginning. Meaning only in two situations the on create will work. Whenever you press the back button, the application is destroyed. So when you want to bring back the application, it has to work from on create. Or your application has not been used for a long time, the Android killed it. Now whenever you want to bring it back, it has to come through on create. And this is how the on create, only in these two cases the on create will come into the picture. Or when you're running the application for the first time, right? So you can have it as three different scenarios. Run it for the first time, you'll go through on create. When the memory is, when Android is struggling for memory, it has deleted your application, and when it has to come in all over again, it'll go to on create. All right. So when you have clicked on the back button and when you want the application back, it will start from on create. These are the three cases that you guys will be onto on create. Right. So on destroy means it is the activity shutdown. So guys, before I move on to intents, let me walk you through a brief code of what exactly you guys have understood till now. Let us see, let us take a quick recap of what you guys have learned. Now, guys, you know all this. Now, I am not teaching you how to write the application and how to write on start, on resume, on pause. And when you bring in, when you start on create, I told you this is the constructor. And now on create is going to be here. And you have seen on start, on resume, on pause, on stop, on destroy. Everything is right there. Now, you know what? Let me compile this code to see what exactly is going to happen. Now our application is running. Now imagine some other application has to come up now. Now in that situation, now let me bring in this. Now let me click on this rectangle. Now you see so many applications are already there. All right. Now let me click on the browser. Now when I click on the browser, you all can see the Google application right here. When the Google browser came up, obviously your application has taken the back seat. That means your application has completely gone out of focus. Now let us go back to this program. Now let me minimize this so that we can have this guy here. Now in this case, you all can see that you're in on pause and you're in on stop. That means your application came into the pause mode and your application came into the stop mode. Now your application is there in the back burner. Now, if you leave it like this for a long time, the Android, if at all, if the Android needs the memory, needs the space, then the Android can even destroy your application. Or if you want your application to be back, by clicking on this, you can see your application back. And let me bring my application back here. You should be seeing your application right here. Let's prepare for Android. Guys, watch me clicking on this now. When I click on this, now obviously you know it is not going to call, now as of now you're in on pause and on stop. Now it is not going to call on create. All right. Now I just click, you all can see it called on resume, right? It just called on start and it called on resume and it came back to your application. Now let me click on the back button, this one. Now, obviously, this has to call your on destroy. Now watch, your application went out of focus. And here, if you see in the logcat, you all can see that it is called on destroy. All right. Now, again, I'm going to click on this rectangle and I'm going to bring this application back. When I click on this application, evidently you all should see on create, start and resume, because after on destroy, your application has to come up all over again. So at that point of time, the application is going to start fresh right from on create. Let me click on this. You all can see you're calling on create, on start and on resume. Guys, that's it. And this is about your activity life cycle. Now, let me go back to my PowerPoint. Yeah. So it's the time for us to understand what are intents. Now, most of you would have been used intents. Most of you would have used intents to the depth, and few of you would have used intents to a very shallow level. Now, to understand the intents happens to be the backbone for your Android, and this intents is originated from the kernel. It is not that you're just trying to call an activity using an intent. There are lots of things that what you have to look at when it comes to intents. Now let us take a brief look on intents. Now when you guys think about an intent, you always think, oh, to call the second activity, being in the first activity, if I have to call the second activity, I have to use an intent. Obviously, this is what will ring in your mind. Now, first activity, click me, it takes you to the second activity and it says you're in the second activity. Now, that is one of the ways that the intent is used, but that's not all. An intent is a messaging object you can use to request an action from other app component. Now guys, do remember, whenever you start working on the activity, an activity is also called as a component, and I'm going to down the line, I'll be explaining why it is a component and how it has been looked as a component. Now, the most important thing is when we talk about the components, as you all can see here, an intent is a messaging object you can use to request an action from other app component. Now, when we talk about a component, here you can see the highlights here. You can see activity, service, and broadcast. Now, you may get a doubt, oh my God, why the start activity is a component? Now, when I say start service, yeah, I agree it's a component because it's a process, it runs in the background, so it can be called as a component. Send broadcast can be called as a component because I'm broadcasting a message. That is what may ring in your mind. Guys, do remember, what you have learned is when you guys create an activity, you guys have created an activity, the nameless activity, and we called it as the component wherein now if you want to write a calculator, now the calculator is of no use for you and you want your calculator to be a component, so any of the other applications which is there on your phone should be able to spring up and use the calculator, and that is how your activity can be called as a component, because in the activity you have written a calculator which can be used by any of the other applications just instead of just using it by your own self. Now, methods are used to deliver intents to different component. Now, whenever you call, you're going to call the components as start activity, start service, and start broadcast. Guys, please do note that you have something called as a context dot start activity. Now in the interviews, and this is going to be a vital question that they're going to ask you, why is that you call it as context? Now all of you would have understood context means, oh, it's like this pointer, this dot start activity. Guys, it is just not about this pointer. This is a world by itself, and this is where they're going to hold you for a ransom in the interview, and you have to have a very good knowledge and an in-depth knowledge about the context, using the context, at what time you're using the context and why context. Now down the line I'll be explaining all these things to you. Please hold on till then. Now how do you call from one activity, how do you call the other activity? Guys, it's fairly simple. Now, when you click on a button, the second activity can be called using the intent. Is it right? All of you would have seen that. Now, let me quickly take you to the code and I will show you probably what is that you guys will be doing. Now here, you are not going to click on any button. Now, let me just say intent. Now, this is how you all are going to use an intent. Now, I'm just going to call it as an intent. Now here, I'm going to call this as this. Now you all should know the meaning of this. That is very important. Sometimes we also write main activity dot this, and then you're going to call the other activity dot class, right? So that is how you guys are trying to fire the other activity, and you're going to call start activity, and you're going to give your intent, right? Now this is how you are calling right from being here in this object, and you're trying to call the other activity, and this is where you're calling start activity of intent. Now guys, I told you this intent happens to be the binder, and this in turn comes from the kernel, and this in turn binds your first activity to the other activity, and you've got a lot of stuff that what you can look at it at the later state and about the intent. Now, as of now, this is how the intent is going to work. Now, when I run this program, you'll not see the main activity. You're going to see that you have landed in the other activity. And that is what you guys are out to see now. Look at this. You all can see that you're in the other activity because I called my intent right here. Guys, this is what you have learned as of now, just plainly about an intent. All right. So there are three components, important components: activity, service, and broadcast. Now they may ask you a question. How many important components are there in your Android? Now, incidentally, when we talk about intent, there is also a subtle difference to this. We also have something called as the content providers. And the content providers are not there in this diagram because that happens to be, it is even more complicated, it is even more powerful than intent, and the content provider in turn indirectly uses the binder to it. And there are four components. There is activity, service, broadcast, content provider, and this is what it is all about when it comes to the components. Now, when it comes to the intent, now we also how to call the start activity, and we also how you ended up in the other activity. That is one way of calling the intent. Now, whenever, in fact, I'll be showing it to you later, I'll be taking you through how to start a service, and that also is an intent. Very soon you're going to see it and you'll understand how to call service and how to call the broadcast. Now, it's all almost the same way that you guys are going to call. Now, whatever that you have seen here so far, now this happens to be the explicit intent. Now we are moving on to the implicit intent. What exactly is that? Now, in the previous case, what did you all do? You said intent main activity dot this comma other activity dot class. That means you knew the name of the other activity to call. But when you do not know the name, I want to call an activity and I don't know the name of the activity. Now the activity has to do something. Now that is when we use the implicit intent. Now let us take a look at the implicit intent. Now, implicit intent is when the target component is not defined in the intent and the Android system has to evaluate the registered components based on the intent data. Now, many of your activities in turn would have been imbibed by intent action view. Now, which activity has to help you? Which activity has to give a service to you? It all depends on the data that what you're given in this URI parser. Now, if the data matches right inside your activity, now your activity is going to come up and your activity is going to run. Now at the same time, now if you have 5 activities that is being imbibing action view, and at that point of time, whenever you're running the program, you guys are going to see the 5 activities, but when you click on a specific application, if that application can deal with this parser www.edureka.co, and your application will be called. And this is how the implicit intent in turn is some other program which is sitting inside the package manager. And when you run an intent and when you call intent.actionView, this in turn will go ask the package manager, how many of you with you has the action view? Then the package manager says, hey, 5 applications has the characteristics called as the action called as the action view. And what do you want me to do with it? And then you're trying to pass the URI parser of edureka.co. Then the package manager in turn will pass this edureka.co to all the 5 applications. Whichever the application can handle, it will handle it. So that is when you guys can call it as a component. You're not going to call it as an activity or as just as an application. Now, without even knowing your application name, and you parsed the, you gave the URI parse in the data, your application was able to catch that and your application was able to execute it. Now, let's take a brief look at this particular point. Now, all that I will do here is, let me see if we can copy, and I'll just go here. And instead of this, I'm just going to, oh yeah, the entire line I've got it, right? So let me paste it here. Now the URI, I have to resolve this error like this, and we have the intent, right? In the previous case, you called with the main activity, comma, the other activity dot class. That was very clear and very specific, and you targeted at it and it said, hey, okay, call him, and it called. Now, in our application, the other activity cannot do this job. Now, we don't even know which application we are calling and who is going to render this work for us, right? Now, we are going to request the package manager. Now, whoever can do it, please let them do it. Now, that is how you're going to call this particular intent. Now, let me run this program. Watch what happens now. All right, guys, can you see that you're able to load the Edureka portal here? And that is what happens. Who did this for you? Nobody knows. It is not your application. And that is why we call an application as a component, and your application, end of the day, your application has to be a kind of service provider. Anybody can use your applications to get the work done. Guys, this is a very interesting concept, and we train for almost about 2 hours just on the intent and how to write this characteristics and all that in Edureka. So if you want to know more about it, and if you want to go really deep into it to the level of your framework, and if you want to write the intents, please think about signing up with Edureka, and you're going to get the best by end of the day, right? So this is what it is. Now let me quickly go back to the PowerPoint. Now what it is called as. The most important thing that you guys should remember, in the interview they're going to ask you, what is an implicit intent? What is an explicit intent? These words are confusing. Now, when it is an implicit intent, the previous program, intent here, new intent of main activity dot this comma other activity dot class, start activity, that happens to be the explicit intent. Now, the implicit intent is the action, and you're giving the URI parser. Whenever you give the action view, action call, action dial, it can be any action, and then the URI parser appropriately to that is what you call it as the implicit intent. Please do remember this, guys, and this question is there for sure, 100% that they're going to ask you this question. Now, once again, we are there with explicit intent. Now, in the previous example that I just took you through, and I showed you how to write the explicit intent, meaning I told you there are 2 ways. There is main activity dot this and other activity dot class, and I started the activity. But whereas in this case, it is just the same. You're trying to see here in the explicit intent, but you're also trying to give the value to put extra. The put extra in intent.putExtra works, acts as the key value pair, and you're giving the key that is a value 1, and the value is, this is activity 2. The key is value 2, this value 2 for activity 2, and these are the values that what you're trying to give it to the intent, and you're starting the activity. Now, this values is what would be transported to the activity 2. So these 2 sentences that can be retrieved in activity 2 with the help of the key, so that you guys should know the value 1 and value 2 to retrieve the keys. Now, when we practically talk about the explicit intent, it is just about these 2 lines. And they may ask you a question, how is that you can transport, how is that you can pass a value? There are 2 ways. One is you can use put extra, and the other way around is you can use bundle, transfer the value from one activity to the other activity. Now, what is explicit intent? Explicit intent is when an application defines the target component directly in the intent. Now, what it is? Now, the target component is activity2.class is directly being given here, the start activity. That's about it, and this is what is called as the explicit intent. Now, guys, you have seen this earlier. Just go back in the video and go to the previous program, and you have already seen this. Now, that's the difference between the implicit and the explicit. Implicit is action view and URI parser you gave. Explicit is you're giving the target class directly, because you know him and you're asking him to come up, and that is what is your implicit intent. Now, another interesting question, what are the tools placed in Android SDK? Now, you have the Android emulator. Now, the emulator is the one that what you have seen so far. I've been running all the applications in my emulator, and that is what is your Android emulator. Now, let me show you that emulator all over again for you. Now, this guy will be hiding here. And when I bring this emulator here, now this, while creating this emulator, now we cannot afford to buy 5 different phones to test the product. I cannot buy 3-inch phone, 7-inch phone, a tablet and a TV and this and that and all that to compile the product. You know what? I can create so many emulators and I can start testing my applications on my emulator. That is what I can do. So this in turn will cut the cost of buying the phone. Secondly, the emulator, the Android emulator that what you guys are seeing here is typically a phone. Now, whenever you are trying to bring up the emulator, it takes all the time the phone takes to come up. And this is working exactly like a phone. It starts right from the board support package and it comes up all the way and it displays the content on the screen. And it's truly a phone. Do not come to the conclusion that it's just a rectangle or it is just a view. I'm displaying my outputs. No. This is truly a phone that you guys are using the phone. That's when you all started creating the emulator, you defined the memory size, you defined the screen size. You said whether you wanted an Nexus phone, you said what is that you wanted, all that you defined, and you brought up the emulator on the screen, right? That's what is your Android emulator. Now comes the DDMS. That happens to be the Dalvik Debug Monitoring Services. This is what happens to be the DDMS. Now guys, the DDMS happens to be a very vital part of your development. Now, whenever you complete the program and when your program is ready to be rolled out and it has to go through the harness test, and that is where the DDMS will come into the picture. Now, let me briefly show you what exactly is a DDMS is all about. Now, let me go back to my app. Now, let me pick some other application just for the heck of it. Now, let me take one shared preferences application here. Yeah. So that I can give you a demo of the DDMS too. Now, I'm just trying to load one of the shared preferences application. As I told you all, that the shared preferences in turn uses the internal memory, that is the file system of your Android. And if you want to watch that internal memory, now you all have to open up your DDMS, right? So let me open that application. Now this is the application. Now still the process is on. Now all that we do in this code is we're going to enter the login and password. The login and password is stored in the file system, right? That happens to be the internal memory and that happens to be the secured memory. Nobody can go see what is there in that memory because it comes under the sandbox. All right, now let us see how that works here. In the meantime, let me compile this before I explain the code or before I take you into the code. Now here in the shared preferences, you guys have given the file name as login Edureka. All right. Now you're going to create the shared preferences in login Edureka. Now whatever the username and password that you guys are going to type in, it will be stored in the file system that is in login Edureka that can be watched using your DDMS, and that is what we are out to do now. Now let us give a couple of seconds for him to finish compiling. So I told you the shared preferences comes in form of the internal storage. The SD card is the external storage. Now we are going to see the internal storage with the help of our DDMS. Now, when you all get to, let me click on Android Studio and I'll go to Tools. All right. So guys, we are back to the code and you all can see a shared preferences application and your login. It is asking me for the login. Now let me say, I'll click here and let me type in Satya. And the password, I'm going to give Edureka. All right. Now I'll say login. Let's say Satya and Edureka logged in. Now this information is stored inside the shared preferences. Now this happens to be the internal storage in your file, right? Now how do I see that? Where do I see that? Now all we have to do is we have to go get our DDMS. So I'm just going to go to tool, but you have to understand something here. We always end up this DDMS Android device monitor and your application, these two guys are rivals. When this application is running, your DDMS will not work. You have to have either of this on at any point of time. So now I'm going to turn my Android device monitor on. Now this is where the DDMS is going to come in. All right, so we have the application. Now here the package name is example cog layout I have given. Now you all can see this as example cog layout. Now one of the characteristics that I'm trying to bring in here, and this is what is your DDMS, and this is how the DDMS looks. And here in this we can check the heap of your application, or we can check the threads of your application, and I can start profiling, I can start method profiling, and I can check like where exactly your program is sluggish. Now this is what is called as the profiling. Now this in turn will start recording your application as it runs, and it starts telling you where exactly your application is sluggish and where exactly your application is good, and so on and so forth. All those information, it gets it for you. And that is where you do the method profiling, and we can do the trace view analysis, and a lot of stuff can be done in DDMS. Now, as we start going further down, and I'm going to bring you back into those explanations. Now, I just wanted to show you what kind of tools Android supports. Now, one of the most powerful and the most important tool happens to be this DDMS. Now, by clicking on the file system, now click on the data. Now we are getting to the internal storage. Click on the data. Again, you click on the data. Now this is where all the files that is available in the emulator in different sandboxes have been shown to you. Now we need to get to example cog layout. This is all COM. Now we have example cog layout, and then you all can see the shared preferences. Now you all can see the login edureka.xml, right? Now this is what is present inside the shared preferences, and if you can see the icon here, it says pull file from the device. I can pull this file out. Now login edureka.xml. Now I just want to show it in my, let me say, documents. Login edureka.xml. I've just stored it in documents now. I'm saving it. Now, being in my file, I can open. I can go to my documents. Let me go to my documents. And there we all know it is login edureka.xml. Let me click on this, and you all can see that I typed Satya and I typed Edureka as the password. Now you all can see this here, and this is the secured information that what you all have stored it in your file system, and that is what is your DDMS, and that is one of the activities that what we all can see. And we saw how to pull the data out of the file system, and only you can do it because you're the owner of the application. No one else can lay their hands on to this. And this is how you can pull the data, and you can see what data is present in your file system. Now, this is one of the characteristics of your DDMS. Now, we have got a lot more to talk, a lot more to discuss. As we start progressing, as we start going further down, I'm going to explain this to you. Now, as of now, what is that you guys have seen is, what is Android emulator? We have seen. Then the DDMS, the Dalvik debug monitoring system, is what we have seen at a very high level. Now comes the AAPT, happens to be the Android Asset Packaging Tool. Guys, now the APK that what you all have seen is being made out of this Android Asset Packaging Tool. And this happens to be one of the tools which is available in your build folder. And whenever the APK is created, and the APK is created, all the files, the jar files and all that, it has been zipped, and it has been put in to the .apk with the help of this Android Asset Packaging Tool. So this happens to be the default tool, and you may not have to do much with this particular default tool. And if you go to the build folder, and you guys will get to see this AAPT. All right. Now comes the other important thing that happens to be the ADB. that happens to be the Android debug bridge. Now, this ADB happens to be the Android debug bridge. Now, whatever we do with the help of the IDE to compile the program and to put the program into the emulator. And we went to DDMS and we pulled the file out of the DDMS. All that work and lot many things can be done with the help of the Android debug bridge without the IDE. Now, this is what can be done. Now, further down, in fact, we're going to talk more about the Android debug bridge. At that point of time, I'm going to show you how to use a couple of functionalities via this ADB. Okay. Now, in this session, you guys have learned about the emulator, about the DDMS, about the AAPT, and the ADB. Now, what exactly is the Android runtime? Now, after the runtime, you guys will hit that AAPT, right? The packaging stuff. Okay. Now, let us take a look at the runtime. Now, it's fairly simple. Now, Android runtime has the Dalvik virtual machine and core Java libraries. In Java, you all saw the Java virtual machine. In Android, you guys are out to see the Dalvik virtual machine, right? Now, DVM is optimized for low processing power and low memory environments. Now, the Dalvik virtual machine is meant to run on this smaller devices with very little memory and very little power. That is nothing but your mobile applications, right? And that is where the DVM will come handy. And that is where you're going to see predominantly you're going to see a difference between the Java virtual machine and then the Dalvik virtual machine. Now, unlike Java virtual machine, the Dalvik virtual machine doesn't run the .class files. Now, the .class files is just the files that what has been created by Java, and it stops right there. And now, henceforth, the .class files is being converted. Instead of .class files, the Dalvik virtual machine will be using the DEX files, right? Now, it uses the DEX files. Now, it really started, the DEX file started coming into the mushrooming up from the Frio 2.2. Now, they got in a lot of other interesting characters into the DEX file. That is, the DEX file, you understood what exactly it is, right? Low processing power and the low memory environments, and the DVM, that is where the DVM comes in, and the DVM in turn will create the DEX files, and DEX file in turn has got something called as the JIT, called as the just-in-time. Now, when it comes to the just-in-time, now that's really very interesting. When your program takes about 3 minutes to compile, after that you would have added 2 more lines to your source code. When you compile, it'll take milliseconds and your program is ready to go. But if you try to do so in other operating system environments, if you recompile, it'll take 3 minutes all over again. But in Java, it doesn't. It compiles only that small little tiny bits of code that what you have modified and your application will run. And that is what is called as the just-in-time. Now, Android 2.2 Frio brought trace-based just-in-time application into Dalvik, optimizing the execution of the applications and dynamically compiling frequently executed short segments of their bytecode into native machine code, right? There is a short segments. The 3 lines that what you have added, it compiles only that, it adds up to the bytecode and it brings it onto the machine, and that way it remarkably it improved the speed of your compiling. Now here you all can see the diagram: Java source code, Java compiler, Java bytecode, and finally it turns out to be the Java virtual machine. Now when you look at it from the Android perception, Java source code, Java compiler, Java bytecode, and then comes the Java. See, till here the .class is there into the picture because you all have seen the other activity had the .class in it. After that, the DEX in turn will take over, and then the Dalvik bytecode comes into the picture, then the Dalvik executable, and then the Dalvik virtual machine will come into the picture. After this, the AAPT will come into the picture and it packages everything into the .apk file. And that's what it is all about when it comes to the runtime. Now again, what is your DDMS? Now we are going to go a little more deeper into the DDMS than what we saw previously. It stands for the Dalvik Debug Monitor Server. it gives the wide array of debugging features. One is the port forwarding services. Guys, this is very interesting, and this has got something to do in depth. For example, you're connecting one of the healthcare devices into the phone. Now the healthcare devices in turn brings the data through the serial port, and the data has to be forwarded to your port. Now that port is a different port, and the port that what you're using on your phone is a different port, and that is when you guys will be using something called as the port forwarding services, meaning you can transfer from one port to the other port, and you're telling your program that, hey, look, from this port take all the data and use it on the other port, meaning from the computer take the data from that port and use it on your Android phone right on this particular port. Guys, there are two ways of looking at it. One is using the ADB, you can do the port forwarding, or by writing the NDK programs, and you guys can start tweaking the data from the port that where the data is coming from. It can be spooled in, it can be read into a file. So after that, from the file, you can transfer the data, you can forward the port data onto the other port which is there on your phone. Now, these are the two different ways that we can use for the port forwarding services. Now, let me quickly take you to the developer.android.com just in case if you have any doubts like this. Now, that is the ultimate guide for you. Now, let me move on to the Android debug bridge. Now, I'm in ADB, and as I scroll down, now you guys will get to see the port forwarding right here. Now guys, if you want to go really deep into it, all these things is being stitched into the course, and you guys will be learning how to write the applications and how to rig it up professionally. That is what you guys are going to learn. And since this has been an interview question, and I'm just taking you through this and I'm just enlightening you what exactly is the port forwarding. Now guys, please take a look. Now this is where it is. Now you have the TCP IP protocol, and the port for the TCP IP protocol is presumed as 6100 from your computer, and that port you want to forward it onto the 7100 onto your emulator. Your emulator port happens to be, or the device port happens to be 7100, and your computer port happens to be this, and you want to transfer the data from, you want to forward this port to the other port, and this is what you mean. Now, you know what, you can just copy this and you go to the emulator. If you are using the Mac, it is terminal. If you are using your Windows operating system, it is going to be your command. And all that I'm going to do is just copy it there and press return, and it's through. It works beautifully, and you all can see, and there is no error cropped up, and you forwarded the port 6100 to the place of 7100, and this is what it means to you. But going deep, it's a different world altogether, and there are two ways. As I told you, using NDK we can retrieve the data from port 6100 and we can push it to the port 7100, or using ADB we can do that. That's quite a bit of job, and the professionals, the companies like healthcare companies and even a lot of billing companies, the people who use the serial communications or TCP/IP communications and all that, and they use this port forwarding very commonly, and it is a must for you all to know the meaning of the port forwarding to be a good programmer. Now let me go back. Now we have the screen capture on the device. Now when you're running your application, now you want to know what exactly is happening at the emulator when your application is running. So at that point of time, you may want to capture the screen. Now let me see how is that it is possible. Now let me take you back to the DDMS because it's already there. And here you all can see the camera, and you all can see as of now we have logged in to this screen. There is a layout, and you all can see the Satya and the Edureka is right there. And let me click on my camera. Right now this guy is going to capture. You all can see it captured the image. Now let me reduce the size of the screen. Now, as we scroll down, you all can see, now this is what it is. Now you all can see 4G808, and there is an image that what has been captured. And if you save, this gets saved onto, see, look at this. This is the device image that what has been captured, and this can be stored onto the document file and in form of a PNG, and that is what it is. And this is how it allows you to take this screen when you're executing your program. So the DDMS. Now this is where you saw how to capture the screen right in your DDMS, and that is one of the option what your DDMS is giving you. That is all about the screen capture on the device. You also how to do it. Now comes the thread and heap information. Now when you're running your application, by default your Android application has a thread in it, and by default it uses the heap, obviously. Now how do you track it? How do you get to see the threads, and how do you know how the thread is running and the behaviors, and how do you check on that? Now let me take you through the DDMS all over again and show you how that works. Now here I've clicked on my example application. Now I told you that I can, by clicking on the heap, this is update heap. I clicked on the heap. You can see this green bin here, and this happens to be the thread and update threads. When I click, you all can see the thread, and I have roped in the thread and the heap into my profiling. Now here, so far you have been looking at your file explorer. Now you can check on your threads. Now how your application has been working, all that information is present here on your threads. And you can also check the heap. Now the heap information cause garbage collector. Now this is the heap information that what you all can see here. And if you guys are interested in knowing more, and you're always welcome to sign in with Edureka. And this is not a simple stuff. If the things would have been simpler, I would have told you how it works and what it is all about. But this needs a lot of time for you guys to understand what it is, right? Now comes your method profiling. Now I stopped the method profiling that what I turned quite some time back. Now here you can see a small window hiding here. Now this is the beauty of Android. Now when I told you your application has to go through the harness test, and this is where your application is landed. And now, because in our application we hardly have said hello world, no, nothing is happening. Now this rectangle that what you guys can see here, and this is where it does all the method profiling, because our application does not have anything. And here you will get to see a lot of blocks, this colors that what you are seeing here, the blue, green, red, and all that, those colors, you will see chunk of blocks, and every color will mean where exactly it is pointing to your program. The bigger the chunk, your program is bad. That means you'll have a lag in the code, and your program is not really doing good, and that is what you guys will get to understand here. Now I just want to take you through the demo, because I'm not taking you through any of the proper applications, just because the applications that what we have been using, through that itself I did this profile tracing, and I'm just trying to show you what exactly is going to happen and how it is going to happen. And that's about it, guys. That's about the profile tracing. And as I told you, all this in turn will consume a lot of time for you guys to learn. And easily I would say a person with about 2 years of experience, he will put his hands into all this stuff, right? So this is available for you as soon as you sign up Edureka. Maybe in the 6th or 7th session, you guys will be working on all this. Now you saw how to check on thread and heap, and also I gave you the profiling, which is not right here. Then comes the logcat. Now the logcat is a very important stuff in your application. Now here the logcat is there at the bottom left corner of the screen. I can click on that, and this logcat in turn will show, it'll take you through the application, and it'll show you the vivid behavior of your application, where the errors are coming and where it is doing good, and all the traces and everything, the PID and TID and the tag of your application, everything gets displayed here in your log, right? So that's about the logcat, and you will get the application traces. Just in case if you go wrong, you will get to know where exactly you've gone wrong. Just in case if you want to have a tag, if you want to trace your application, the logcat is going to help you. And this is where you all can see the logcat in your DDMS. Now, it is not about logcat. Like where you see the logcat in DDMS is what is the question. Now, incoming call and SMS spoofing. Now, how do you know that you have an SMS, or you want to pretend as though you're going to send an SMS to somebody else? Now, there are two ways. Now, I'm just roping in my emulator. Now, I'm going to click on these three dots. When I click on the three dots, you all can see it is about the location. Now you see the latitude and longitude, and I can spoof the information, meaning I produced it, and by clicking on send, this information will be sent to one of the emulators. This is what you call it as spoofing. Now, because you're working on the emulator cannot really get the locations, or it cannot get the cellular information, or the battery, or the phone. Now, look at this. This is where you're trying to send a message, SMS message, to your emulator. This is what you call it as spoofing. Now, can you all see this? Now, you received it, right? So you all can see the nugget is sweet. Now this is what you have received. This is what you call it as the message spoofing. But guys, watch the difference. Now the PPT says that is in DDMS, but I am showing you the location spoofing, cellular, battery, phone spoofing, everything right at the emulator. Now earlier it used to be in DDMS, and the DDMS is not supporting this information anymore inside the DDMS, and they have given all this stuff to the emulators, and by clicking this three dots right at the emulator, and this information's or this things is available in emulator. Please do not go back to DDMS for all this stuff. Just to confuse you, they may ask you in DDMS, take me to DDMS and show me the SMS or location spoofing. Now in DDMS it is not there. It is as simple as such, and you have to come here and you can check on all this stuff. All right. So let me close this and let me push this guy back, and let me go back to my slides. Now let us see where we are. Now guys, you all saw the SMS spoofing, and you all saw the location data spoofing. There is the latitude and longitude also can be spoofed in your emulator itself, and this too cannot be seen on the emulator anymore, sorry, on the DDMS anymore, and this you can see it right on your emulator. All right. Now, what exactly is the meaning of the file, folder, and the app? Like, explain briefly about the important file and folder when you create a new app. Now, all of you know that when you create an app, this is what you guys will get to see, out of which when you see this app, you will see this manifest, and there you will get to see the manifest file. In Java, you all will see the app file in com example aishi.myapplications. There you guys are going to see the apps, whatever the apps that you're going to write, and when you click on this arrow, you're going to see main activity application right here. Now this Android test and Android, the other small little thing that what you're trying to see here, this is for testing. Like you guys are going to learn about the espresso test and unit test and all that, and that testing is going to come in these two particular packages. And as of now, the app comes under Java and under the first package. It describes the fundamental character of the app and defines each of its components, right? Now, getting back, sorry, this app is all about the manifest he's talking about. Now, getting back to the Java, this contains the .java source file of your project. By default, it includes main activity.java source file. Now here in this Java, in this first package, you're going to have the main activity source file. In the app, everything related to the manifest has all been stored, meaning the app in the manifest, that whatever the information that you guys see under the app is the fingerprint of your application, and that's what is stored in manifest. Under Java, the file, that whatever the file, main activity that what you have created is what is being stored here. And in resource, it is a directory for files that defines your app user interface. Now in resource, if you want to put all the pictures, it can go into drawable, and the buttons, icons, pictures, it can go into map to load that onto the various devices and various size of the devices. And in layout, you guys can have your UI, and in values, you can have your strings, dimensions, and locales, and all that is going to go there into it. Now, comes the Gradle scripts. Now, this happens to be the auto-generated file, right? You are not going to do anything there, and it is automatically being generated. Now, that in turn will have the various build versions, compiler versions, and the SDK versions, and the tons of other stuff like the flavors, ProGuard, and lot many things. And we don't have the libraries anymore in Android, and those are the dependencies that what you'll see in form of dependencies. You'll see libraries in Gradle. All the stuff will come into Gradle. Now, Gradle is just not one line. It cannot be explained in about 5 minutes. And you guys have to grow with the Gradle right from day one till you complete the course. And throughout, the Gradle is being taught to you, and how to use and how to implement your own stuff, and all that is being taught to you. And the Gradle happens to be a very important property of your applications. So that's how you guys can look into these important files and folders when you create a new app. Now, what exactly is the manifest? Now, I told you guys that the manifest file is where your fingerprint of your application is stored. Now, let's take a look at the manifest. Now, in fact, I walked you through the manifest when I opened my application. Now, the manifest file provides essential information about your app to Android system, which the system must have before it can run. Now, for example, what exactly is the main activity here? No, it is going to tell your Android that, hey, the main activity happens to be the launcher, and he is the launcher and he is a key guy who's going to run. Now, what kind of an icon that you want to have when the application is installed in the emulator on the phone? Now, in the MIP map, you would have put a nice butterfly, and you may say, hey, that the butterfly is the icon that I want, or my company icon is that I want to pull in. And what do you want to call your application as, and so on and so forth. All this information is being bundled up in the manifest. Now, whatever the information that you have in the manifest is being conjured up by your package manager. Now, if you have 10 applications in your emulator or in your phone, you'll have 10 manifest files. All the manifest files is being stored, and it is being taken care of by the package manager. And package manager is responsible to take care of all the applications what is running in your Android. Now comes the exceptions. Now guys, all of you know the meaning of exceptions, and you have seen how to create exceptions in Java, and you know most of it. But in Android, we too have exceptions in Android. Even when you're using sleep, now you have to raise the try and catch block, right? Even that in turn will generate an exception. So as you have a lot of exceptions being generated, out of which you guys can find the inflate exception. Now, when you have the layouts like constraint layouts or relative layouts or whichever the layout, and if you give a typo for the text view, just say TEX, T view, VIE, forget the W there, and it while inflating, it finds that as an error, and it gives you the inflate error at that point of time. Very similarly, you have surface out of resource exception. Now, just in case, I may teach you all this, but just in case, if you want to figure out how exactly this works to you, now it's very simple. Now copy this and don't go to Google, okay? Now that's what most of you will do, but I don't want you to do that. Please go to developer.android.com and just paste this right here. And this is when you guys are going to get the right information. Now, surface out of resource exception. Now, what exactly is that? It is already there. Exception thrown when canvas couldn't be lock canvas rectangle, or when surface texture could not successfully be allocated, right? Now, the canvas has to be locked for many reasons, right? When you're trying to render an image, you don't want something else to happen on top of that surface. So you want to lock. And just in case if you're not able to lock, or if anything, if you're goofing up at that particular point, now it will give you the exception thrown that when the canvas cannot be locked, and that is what you call it as the surface out of resource exception. Now, very similarly, you have surface holder bad surface type exception, right? So now guys, this is the authority for you, right? So you just put that right here and you have your answers. And you guys have learned how to use the Developer Studio also at this point of time. Now you need not even have to click here. It says, okay, there's nothing much here. Now, it is again the same exception that is thrown from lock canvas when called on surface. Those type is surface type push buffers, right? So the same, almost a similar kind that you all can see here. Now let me go back. Now comes the window manager. Now I told you about the window manager. Now he manages the frame. He manages your applications. He manages the view of your applications and so on and so forth, right? So that's what it is. Now this error. No, it's very difficult to remember the exceptions. It is not just about the 4 exceptions. There are hundreds of exceptions for you. But the most important exception, the people who tend to ask, because these are the elementary stuff that what you'll be working on. So you have to know about this. Now, exception that is thrown when trying to add view, those whose window manager layout param token is invalid. Now, that is when you're trying to add the view, when the tokens are invalid, and that is when the view cannot be managed by the window manager, and then it says the bad token exception, right? So this is the feeler of your exceptions, and that is how the exceptions are occurred. Now name the dialog box which are supported in Android. Guys, this is fairly simple. Now you have the alert dialog. Now the alert dialog is something like this, that what you all are seeing here to the right. It's a simple dialog. It comes with the OK and cancel button. It's a white dialog, nothing so fancy about it. And progress dialog, no, we have 2 dialogs. One is the spinner, that is a circle will be in front of you all the time showing the progress, or a bar in turn will show the progress, and that is what is the progress dialog. In progress dialog we have spinner and the bar. Now date picker and time picker dialog, or the dialogs which has already been created. Now let me show you how to get that and how it looks. Now let me take any of the resources. I'll just go to layout, and let me go to one of this file, and let me say I just want the time picker. Now I'll just say time picker, wrap content, and that's about it. Now when you click on the design, you all can see the time picker dialog. Now this is how the time picker dialog will look like. Now you can drag, when you integrate your code, when you drag the hand of 8 to 12, and the time will change to 12 o'clock, right? And that is what you can extract, and it can be displayed on your code. And this is how the time picker dialog will look like. Now comes to the date picker. It's fairly simple. I'll just type in the date right there, and you all can see the date picker. And under this, you guys are going to see the calendar. You can see the date. And by clicking on that, and you can extract the date, what the user has opted for, right? So that's about your date picker and the time picker dialogues. You have seen alert dialog is similar. Progress you already have seen. Date and time picker is what you have seen just now. Now comes yet another question that's very interesting. What are the core building blocks of Android? Now guys, you have already seen this. Initially I told you activity as a component, service as a component, broadcast receiver as a component, but I told you there's a subtle difference with all this in the content providers. And now an activity is a screen represented of any application in Android. Each activity has layout file where you can place your UI. Now there are 2 ways of looking at it. One is just as an activity. Now the other one is in form of a component. That is where the implicit and the explicit intent came into the picture. Now when it is being looked in form of a component, the intents will come into the picture and your binders will come into the picture, and that is where it is one of the building blocks in your Android, and it can do a lot more than that. Now in Android, we are not going to look at an application as just like a Java application as a UI and an application. Now we are going to see every activity in form of a component, because it is going to be independent and it is not going to do anything for itself. It can of course do something for its own self, and that in turn, the activity in turn can cater for somebody else, like your calculator. Like in any of the applications you can write inside the activity, wherein it can service others. Now content providers, as I told you already, that in turn can share the data among the sandboxes. Now, when you have 5 different applications running on your application, running on your emulator, all the 5 different applications are using 5 different sandboxes. Now, I want to use one application data everywhere. For example, let me say contacts. Contacts, when they write, they would have written the contact application. They would have stored all the data in form of SQLite. Now, when you get the data out of SQLite, and when it has to be used by others, we have to bring in the wrapper called as the content provider on top of SQLite, and that is how the content provider in turn can take the data from one of the sandbox and it can be given to others, and that is where we use the content provider as a wrapper on top of your application, right? To take the data and give it to others. Now, service. Service is a component that runs in the background to perform the long-running operations. Now, guys, you may have a doubt that, oh, can I write a thread that can do downloading job from the server? Now, the answer is no, because when the application dies, the thread also will die. So employ the service so that when the application dies, the service will not die. So service then can do a better long-running operations without interacting with the user, even works if application is destroyed, right? So even if the activity is destroyed, the service will go on working and it will download the data and it finishes the work. And that is where it has been predominantly been called as one of the important components. Then comes the broadcast receivers. This in turn can receive the data from any other hardware equipments or from the other applications from a different sandbox, can send a broadcast to all the applications which is there in your device. Now in broadcast, you have local broadcast, you have remote broadcast, you have ordered broadcast. Guys, the local broadcast being in the project, sending the messages among your activities, the local broadcast. Remote broadcast is broadcasting among all the applications which is present in your emulator. Ordered broadcast is when you receive, in what order that you want to receive the messages. Now, I want to be the first person to receive the message. Now, after receiving the message, I can even abandon the broadcast itself, or I can ask the other guy also to receive the message as the second person. So that way you can declare the ordered broadcast, and that is how the broadcast works. And these are the 4 important components that what you guys can see in Android. Now, guys, it is not that whatever you're hearing now and that is all is going to happen. Now, when the companies are working more deeper in services, they're going to drive you crazy. They're going to take you deep into the services. Now here we are trying to give you the highlight of what is what, and we are making you feel very comfortable with the contents and stuff, and you'll be able to talk your way through. But if you want to go really deeper, now you have to take up a course. You have to take it up with some authorized people, so like Edureka, so that you're going to get the complete stuff and you'll be made perfect and you'll be taught everything in detail, right? Now, just for an example, now the content provider, I told you, the SQLite, on top of SQLite, there's a wrapper, that's a content provider. Content provider can start giving the data to others. Now, Google has started a new searching feature in Android. Now, the Google in turn will not really search through the web pages. The Google in turn can come into the Play Stores and it can search through all your applications. When Google is searching through your applications, if your applications has been made shareable and if your application has the content provider, now Google in turn can come right into your application, it can pick the data and it can go give it to the world. So that way you can start sharing your applications and you can have in fact, we can incorporate a search option on top of your content providers, and the Google in turn can come all the way through to the Play Store. It can come through the search, it can go to the content providers, and it can pull the data out and it can give it to the user. So there are a lot of other creative stuff that what we can do. So do not treat just content providers as content providers, services as services. Services has got a lot many things to do with ADL and components and all that. Broadcast receivers too has got a lot many stuff. Now, what you guys are seeing here is just about the high level scenario, all right? Now comes the content provider. Now this is the SQLite database, the app database that what you're trying to see here. Now that is wrapped up with another wrapper. Now what you see here, the query, insert, update, delete. Now all this comes under the framework called as a content provider. Now the content provider acts as a frame on top of your SQLite. Now the other application can query the content provider. The content provider will read the data, gives it to the other application, right? Now this application can be a search application, the way that you all search on your phone. On top you will see the Google search, right? Now when you search there, it will search the data externally in your phone, and it can also search the data internally. At that point of time, it can come through the searchable activity. It can come to the content providers, and it can go to the SQLite, it can pick the data and give it back to the main app. Or even it can give this back to the Google also. There is one more layer where you can create on top of this, and that is how interesting your components are. Now, we have seen service, but what is a service in Android? Now, it's a background process. Even if the application dies, your service is going to run, and that's what it is. Now, the local service is accessed within the application. Now, within the application, you can have a service, but you can have a service in the remote applications also. The service is accessed remotely from the other applications running on the same device. Now, in this case, we have to bring in the AIDL, that happens to be the Android Interface Definition Language, to share the data between two different sandboxes. Now, the AIDL will be vehement and it will do all the job for you. Now, it says, hey, this is how you can extend the service and you can implement the program. The most important thing that what you have to understand here is when the service dies, your application will not die. The service will go on running. Now, please do understand, the service happens to be a part of Android, but your main activity dies, but the service is still on. That is an unbelievable stuff, right? Now, let us quickly go take a look at the code and see how that works. Now, let me come back to the file. Let me open up one of the applications in Edureka. Yeah, let me use the media player. So that will be really very interesting for you so that you all can listen to the song. See, in fact, a service can be the location provider also, like the Google Map. Now, when you're on Google Map, you're listening to the song also. And whenever it happens to be the turns that you want to take, and the Google Map in turn will start talking to you, take a right turn at the circle, but the song will go, the volume will be reduced, and then the Google Map comes up and says take the right, take the left, and go around the circle, and so on and so forth. That means your service is still on, isn't it? So that is how the service works. So service works as the background process, and even if your main activity dies, the service works. Now guys, you all remember that when I press the back button here, obviously your main activity will die, but you'll go on listening to the song. Your song is not going to die. Now, if you all can see, it's just about a small application that I have just written using 2 lines. Now, let me open it and I will show you how to activate a service. Now here you all can see start service. Inside that you're firing an intent. In intent you're giving this. This happens to be the main activity.this and media player audio.class. Now this is where you saw the activity can be called using the intent. So start service, stop service can be called using the intent, and even the broadcast can be called using the intent, and even the content provider uses the intent and binder, and that's how these are the most powerful components in Android. These are the 4 powerful components in Android. Now let me start service. This application is called as Service Media Player Basic. So this is a kind of slow song. Gradually he takes over, but you all can listen to it now. All right, you all are listening to the song, isn't it? Now what happens when I click on the back button? No, I told you very clearly, your application will close. Definitely, your main activity will close. The service happens to be a part of main activity. If that is the case, the service also should close, isn't it? Now let me click on this. So did your song stop? No, right? So it is on. The service is on. Your activity is no more, your activity is dead, but your service is on and you're still able to listen to the song. That's how when you're listening to the song, whenever you come out of the song and work on the other application, you can still listen to the song. This is how it works. Now, if you want to go back, get your application back, right? So I stopped the service so that I brought the application back, then it has come back to onCreate, it started the application all over, and when I clicked on the stop service, now you entered this main activity and then you entered this stop player and it went and told the service you stop it now and it stopped. So somebody has to start the service and somebody has to stop the service, or there are ways that the service can stop by itself, and this is how you guys have taken a brief look on the service. Right? So that's about your service. Now, this is a very interesting question. What are the different types of services? Let's see what is it. First comes the handler service. Now guys, you are trying to avoid the AIDL. That happens to be the Android Interface Definition Language, and you're trying to avoid that, and you're trying to communicate between two different processes in the sandbox without the ADL but using the handlers. The advantage and disadvantage: the handler service in turn can deal with only 1 MB of data. You cannot send as much of data as you want into the other process. You can deal only with 1 MB of data. The handler services will work on the thread and it is asynchronous. Now, only one thread you can execute. You cannot bring in multiple threads into the handler services. Now, one thread has to talk to the other thread. Now, this can be like a single chat application, not a group chat. Now, you can talk to me, you can send me a text and I can send you a text. You can send me a small picture, I'll be sending you the small picture. And this is the kind of work your handler service can do. Then comes the intent service. Now, the intent service is more or less like your asynchronous calls. That means if you want to download a photograph from the server or a movie, and you tell your program to download the movie from the server, it downloads the movie and the service stops by itself, and that is what you call it as the intent service. Now we have the third one is the service, and this happens to be the most powerful service. Now when you start the service, there is no end to it, and it goes on and on and on for days together if you want to. Now the way that we went in and we stopped the service, that's how we have to go in and we have to stop the service. Now this, like, it can be the intent service or the service. This in turn can support the ADL also, wherein you can bring in the function so that it can start talking between the different process, and that is how the ADL comes into the picture. And this is how the services are laid, and this is how the services works, and at a very high level. But we have got lot many important things to understand and to know about the services. Depending on the experience and the intensity, the people may ask more questions like how to write a plugin and how to make the remote services to understand with each other, and how to make that to communicate, and so on and so forth. The people may ask, and that happens to be a kind of advanced questions, and all that is there is a part of your course, and that happens to be the integral part of your course with Edureka. So guys, we have just seen the different types of services so far. Now comes even more interesting question. What is a service and a thread? When thread 2 can work for a long time, why not a service? But we have a problem. When a thread works for a long time, the choreographer in turn will start throwing an error. It says, hey, you've been working for too long and you're holding the parent thread on a ransom, and you cannot do that. So you have to spawn the other child thread. Whenever your application dies, the thread 2 will die, and that is where the thread lands into the trouble. Now let's go quickly take a look at the differences. Now when you all see the thread, since I already started talking about it, let me explain this to you. A thread is a concurrent unit of execution. That means it is the time slicing. It gets 1/4 of a millisecond to execute the task. After that, the operating system snatches the control from the thread and gives it to the second thread, and the thread works in form of the round robin concept, right? By default, all components of the same application run in the same process and thread called as the main thread. That is where the thread gets overloaded That is where you guys have to spawn a child thread, and you can have as many child threads that you want. But when your application dies, all the threads will die. Do remember, that is where, that is what is the disadvantage that you will see in threads. Thread is killed when an application is killed. Now, Google has brought in a beautiful concept called as the handlers and loopers into the Android thread. Sorry, it is not Java threads, into the Android threads. Now, the handlers and loopers are not a part of Java, and that happens to be a part of your Android, and the very interesting concept. And using this, we guys can start building the messaging architecture between the objects. Like, we can even say how the objects in turn can talk with the other objects, how an object in turn can deal with a lot of multiple objects, and all those things can be dealt with the handlers and loopers in Android. It is not Java. Please do remember, Google has brought in handlers and loopers into Android threads. Now coming to the services, now when there is a lag executing the program, and the choreographer and when the Android emulator will start throwing in ANR, Android not responding error and all that, and that is when we have to take a turn and we have to think about the services, how to write the program in a better way. Now that is when forcefully you guys will be moved on to services. Now services is like an activity but has no interface, right? Now, service is a part of the activity, but service in turn will go on its own, and it cannot talk, and there is no interface to the activity that we have to build on our own using the handlers and looper, or we can talk from service to a thread or to the activity using your broadcast. Broadcast is not a good idea, but using the handlers and loopers you can talk, and there are many ways to talk between the service and activity. Now, service is not a separate process. No, it works in the background until the service or someone else explicitly they stop it. Now, service happens to be a part of your activity. Please do remember, that's where it has been highlighted, and it is said that the service is not a separate process. Service is not killed when the application is killed. You saw an example right now, right? So you all have been hearing the song even when I came out of the application. It exposes some of its functionality to the other applications by calling bind service. Now, the bind service is a beautiful concept in your content providers. It's a beautiful concept when you have to talk between two different processes. The bind service will come into the picture, and this happens to be the property of kernel, and that in turn throughout Android framework the bind services and intents are used. Let's take a look at the fragment. Let us see what a fragment is all about. Now it's fairly easy to understand. Like when you all created an application, an activity had an UI, but fragment is different from the way that you have seen the activity in UI. Now first, the fragment is part of an activity. Now fragment is not a different program, or it is not a different element. It happens to be a part of the activity. If the activity dies, the fragment dies. If the activity passes, the fragment passes, and it's so on and so forth. So the fragment happens to be a part of activity. You can combine multiple fragments in a single activity. Now when I talk about the fragment, now I can call a fragment as many different slices of the screen. Now you can see in the second example, second UI, you can see two different blocks, right? One is the header and body kind of a thing. Now in an UI, I can have two different blocks, or I can have 5 or 6 or 10 different blocks. And that is how the fragments have designed. Now you can combine multiple fragments in a single activity, which helps us to display multiple screen and reuse the fragment in multiple activities. Now the fragments you can add, you can delete, you can change, you can do all that. Now when the orientation changes, you need not have to bring in another UI. You can rescale the fragment and you can replace the fragment on the screen, and you can fill the screen up and you can start using it so that you'll not be calling the UI. So the fragment happens to be very powerful compared to the regular activity and UI programming, and you can do a lot of stuff using fragments. Now, what is the difference between the fragment and activity? I told you the fragment and activity is one. When the activity is created, the fragment also becomes a part of it. Activity is typically a single focused application that a user can perform, such as dial a number, take a picture, send a mail, view a map, etc. Just a single application. Now when you are using the dialer, something else cannot happen. Now by creating the fragment, now you can divide the screen into many different pieces, wherein if I want to see a message like a banner data, now I can have a screen wherein constantly my share information will be scrolling on the screen even if the call comes in, or even if I am on the map, right? So that way you can create fragment and simultaneously all the fragments can work together, or it is up to you how do you want to use it. Fragment is a modular section of an activity with its own lifecycle and input events, right? Because it has its own lifecycle the way that you have seen the activity, and which can be added or removed. Now, the fragment also has the bundle, and it can store the information in bundle the way that you have seen an activity, or you can add the fragment, you can remove the fragment that what you have created. And also fragments lifecycle is directly affected by the host of activity lifecycle. As I told you, when the activity passes, fragment passes. When the activity is destroyed, fragment is destroyed, and so on and so forth. Now comes the APK. Now guys, it's very simple. You all have seen how the Dalvik virtual machine comes into the picture. Now when you come to the bottom of the diagram, the APK is generated. It is as simple as such. Now APK stands for Android Packaging Kit. Android Packaging Kit is compressed with the classes UIs, support your assets and manifests. All these files are compressed into a single file which is called as the APK. That is AAPT, right? Now there is the Android Packaging Kit. That is what you have seen earlier, and it is, again, it has been explained to you. Now this is a beautiful question. Now will Android support any other language other than Java? Now guys, you already have the answer. Do you remember the green block that what I've been talking about? That is the NDK. NDK supports your C and C++. NDK in turn can talk to the kernel. Your Java cannot talk to the kernel, right? That's what you guys have learned. That's what it is. Yes, Android app can be developed in C and C++. It should be used with the NDK, Android NDK, that happens to be the native development kit. So while installing Android, you guys have to install the native development kit too. And Android SDK software development kit. Now both has to be installed to run your applications. Now when you want to talk to the hardware, like you want to talk to the camera driver, like you want to zoom in, you want to zoom out, and you want to do such stuff, now you have to write an NDK program. That NDK files in turn is called as the .so files, and that in turn will talk to the hardware, and eventually the .so file will talk to the application managers. The application managers will take the data all the way up to the application level, and it is being given to you, and that is where the NDK comes into the picture, right? Now please do remember, NDK is not a part of your Android course, and NDK is a different animal by itself. And that happens to be a different book, that happens to be a different course, that what you have to take it up. Now is the content provider. Like already you have seen the content provider. Now you got a little more in the shelf. Let us see what a content provider is all about. Now content provider manage access to the structured set of data. It is a standard interface that connects data in one process with code running in the other process. This is what I told you guys earlier. Now, when you have the data in one process, that can be shared by the other process. You may ask me, can you show me what exactly is a content provider in the emulator or in the phone? Now guys, please take a look at your contacts. Contacts is, eventually it's an SQLite database. The content provider has come on top of it as a wrapper. Now the contacts can be used by any of the other applications which is running on your phone or the emulator. So as your calendar, so as your SMS, all these are the content providers. Now if you write your application to store all the movie information and data and all that, what do you do with that information? You'd love to share it with others, right? So bring in a content provider. That way you can start sharing it to others, and everybody can start accessing your data, updating the data, and they can do all that. Now they encapsulate the data and provide mechanisms for defining the data security. Now the data what is going to go out of your sandbox is going to be a very secured way. Now you can, the people, they can sign in, they can use the permissions, they can have permissions to use. All that security can come on top of this content providers. Content providers are used to share data between different applications. Obviously, you know that. Now it is implemented as a subclass of content provider class and must implement a standard set of API that enable another application to perform the transactions. Now you guys are going to extend the content provider. By extending the content provider, you saw in the diagram that you have onCreate, and there are 4 different functions that what you have seen, and all that functions is being overridden automatically. There is implementable function comes in and you have to implement those functions in form of the wrapper. Please take a look at the diagram once again. Now let us take a look at the singleton. Now the meaning of singleton itself says it all. That means an object is going to create a single instance. Now let me give you an example. Now you have a server or a login. Now you want to log in by typing in your username and password, or you want to log in by speech recognition, or you want to log in by Facebook or by Google or by LinkedIn. Now all that you do is on the single object. When a guy is trying to log in through the various sources, you don't want to create many objects. No, you want to create a single object. Now however you come in, you have to come in through one single entry. That is what you call it as the single instance. Now the other example could be you have a Citibank. 1 million people in a day, they want to enter the Citibank. They want to access the data and resources in Citibank, so that you practically cannot create 1 million objects to let 1 million people enter the Citibank. Now that is where we create a single instance wherein everybody will get only one handle. Through that, the 1 million people, it is only one object is created. Through that, 1 million people can walk into that particular object. And that is the whole idea of creating a single object. Now here, how exactly that we can do this? Now it's fairly simple. Now we have to stop multiple people creating multiple objects. So all that you do is put the constructor into the private area. When you put the constructor into the private area, now people cannot create the object. Then create an instance variable, a static instance function. The user can access the function even without creating the object. And if the object is not created, they're going to create an object being in that static function called as a get instance. Or what they will do, if the object is created, they will return the same instance back to the user. Now guys, if you have a question on this, it is fairly simple for you to take a look. Now let me briefly show you how to get to that. Now let me take one of the examples, and here I'll right click and let me go to new, and let me go to other. Yeah, it's right here, singleton. So just before the activity, you'll get to see the singleton, and I'm just clicking on it, and I'll call this as Citibank. I'm just going to call this as Citibank singleton, and it creates a complete class for me. Now you all can see the most important thing is you have created a static function called as the Citibank, and then you're constructing an object. All right, now here you have the get instance. Now when the user is trying to use the get instance, you're returning our instance. All right, so what is that you're trying to do? You're creating the object here once, and whenever the people call, you're returning our instance. Now here you have made, please do remember, you have made, this is what I told you, you have made the constructor as the private. When it is private, nobody can create an object. Now the people can access this object only through get instance. Now when they call the get instance, and you always return our instance, what is already been created. And now let 1 million people call, you'll be returning the same address over and over again. And I have simplified it, and this is what is the meaning of singleton, and this is how you guys are going to use the singleton. All right. A singleton class is a class which can create only an object that can be shared by all other classes. Okay, that is your singleton. Now, what is the difference between file, class, activity in Android? This is fairly simple, guys. Now, file is the file. It's a chunk of arbitrary information or resource for storing information. Class, you know the meaning of class. It is a compiled form of Java file. Android uses a class file to produce the executable APK. .class in turn gets converted to APK. This is typically the Java class, and that gets converted to the APK for the execution purpose. Now, when it comes to activity, this has already been explained to you. An activity is comparable to frame window in GUI. Now, in your regular Java, when you go to the frame window, applets and all that, and to that screen, it can be compared. GUI toolkit, it is not a file or a file type. It is just a class that can be executed. Android for loading UI elements on view. Now, in fact, you need not even have to take the difference, or you need not even have to compare yourself with the frame window, GUI and all that. And I have made it very clear to you about the activity. Now, the difference between the activity and UI. UI happens to be a part of the activity. The activity in turn will inflate the UI so that the screen will become visible for you. And the activity as such does all the background job after bringing up the UI element on the screen. Now, that's about your file, class, and activity. This happens to be a very simple question. Now, what is a Dalvik virtual machine? Now, this in fact, we have been discussing over and over again because you're going to get questions on this. And you already have the answer. Dalvik is the name of Android virtual machine. You guys know about it. The Dalvik virtual machine is an interpreter only virtual machine that executes files in Dalvik executable format, that is .dex format. Now, you guys know how the .class gets converted and all that you have seen in the earlier stages. The virtual machine is register based and can run classes compiled by Java language, compiler that have been altered into the native format using the DEX tools. Now, whatever that you are trying to see here is already been explained to you, and that is what is a Dalvik. And now the Dalvik library in turn is envisioned to provide a familiar development base for the user programming with the Java Standard Edition, but is greatly expected for needed small mobile devices. Guys, do you remember that I told you that Dalvik is going to help you to run the application on the small mobile devices when you have the memory constraints, space constraints, processor constraints and all that. And that is where the DM will come handy, and that is where your applications is going to work. And whatever that you guys are seeing here in the question 28 has already been dealt with in the previous slides. What is the significance of DEX files? Now, DEX files is Dalvik executable files which are zipped into a single APK file on the device. Now, the APK file that what you see is nothing other than the DEX file. It has been zipped and it has been put into it with the help of your AAPT that I have already told you, right? Now, DEX file can be created by translating compiling applications written in Java, and DEX file is a format that is optimized for effective storage and memory mappable execution. Now, this is something like a old wine in the new bottle. Now, the DEX is a format that is optimized for effective storage and memory mappable executions. Now, I told you the DEX files is predominantly, it has been used in the smaller gadgets, wherein when you have the memory problem, space problem, processor problem and all that, and it is very efficient in executing in the small environments, in the small devices, and that's where we bring in the DEX files. So it is almost a repeat. Now comes an interesting stuff called as the toast, and this happens to be the most easiest question that what can ever be asked. Now, all that you do is to print the notification for a couple of minutes, we bring in the toast. Now, when you set the alarm, now the toast in turn will pop up and it says, hey, you have set the alarm and you're going to wake me up after 8 hours. Now, that is what the toast says. And that is where we use the toast. Toast is normally used to display the short messages, and it comes up on the screen and it vanishes. Now, notification automatically fades in and fades out, not accept interaction events. So there is absolutely no interactions, and it just comes for about a few milliseconds, and it says that you're going to sleep for 8 hours, and it just vanishes. Now, the syntax is this. You say toast dot, so the very minute you type toast, everything will come up for you. Now, let me show you this, so it'll be more easier for you to understand. Now, I presume that you guys have already written a program. Now here, let me say, just before this, I'll say toast. Now, let me call this. The entire thing comes in here, and let me call my this. And here I will say singleton created. Now what it does is this in turn will be shown, this message singleton created will be shown for about a milliseconds at the bottom of the screen somewhere here, and it vanishes by itself, so that it does not have any control. The user cannot click on any key, or they cannot control, or they cannot do much on this particular toast, and it is predominantly used to display the short-term messages. Now, it is not exemptions. What are exceptions in Android? Now, we have already dealt with this. Now, we saw, in fact, I took you all to developer.android.com. I showed you what is the what are the exceptions. I explained the meaning of exceptions in Java. I told you even the sleep has an exception. We'll have the try throw a block on top of it. Very similarly, we have various exceptions which is running in Android, out of which, just because this are the most commonly used exceptions, now please refer back, and all these exceptions have been explained to you. What is the use of web view in Android? Now there are two ways of looking at it. One is, if you want to bring in the Edureka portal right into your Android without even writing a single line of code, or without even trying to spend too much of time, we can use the web view objects. Now, practically speaking, this web view is a part of Java. It is not the native on Android stuff. That's what I told you earlier. And you're bringing it in, and this in turn can slow down your system. And it's not a real good idea to bring in the web view, because completely this happens to be the Java library. But this in turn will make your life more easier. Now, web view is a view that displays the web page inside your application. All right. Now, if you want to scroll back, if you want to go back to the previous page, next page, home page, it supports all such features and characteristics here. And in order to add web view to your application, you have to add web view. Now, this web view has to be added in your layout, to your XML layout file. Now, let us go quickly take a look now how this in turn will look like. Let me go to one of the activities here. Now, all that you do is you just type in web view. That's it. And content, and that's about it. And this is what is your web view. And probably you may give a handle here, and I'm going to call this as web view. And this is how you're going to declare the web view to use the web view. Okay, that's what is that you guys are seeing here. In order to add web view to your applications, you have to add web view element to your XML layout file. That's all that you do. And about 4 lines of code that you can bring in the complete Edureka portal onto Android, right? So that's more easier, and it is more simpler. But at the same time, it is slow. Now guys, this is the most important thing. 100% they're going to ask you about the context in Android. What exactly is the context in Android? Now, initially when we started, we had something called as get context. Even today it is there, but this is slightly phased out, and the Android, they stopped using it. Instead, they got in this pointer and get activity. Now, this pointer happens to be the address of the object imbibed with the UID, and get activity also does the same thing, so that it very clearly gets the address of the current activity. That is what your get activity will do. But when we look into get base context, this is a kind of dangerous proposition. Like you guys have to know where to use it. Now, you simply cannot say in toast get base context of hello, you're here. No, that is really wrong. Now, get base context in turn is going to reflect on what you're using. Now guys, if you remember, if you go back to the previous slides, 4 components of Android. You all saw context.start activity, context.start service, context.start broadcast. Now, when you look at the start activity, service, broadcast, content provider, and all that, the return type is context. Now, we do have something called as the wrapper, that is called as the context wrapper. Now, whatever returns is all the context type, context object. Now, to tell you honestly, the context class happens to be an abstract class. Now, this in turn can return the numerous context. Now, if you are in service, it will return the service context. If you are in activity, it will return the activity context. If you are in broadcast receivers, in broadcast receivers, the context are controlled, and it sends that context back to you. Now guys, you have to be really very careful. You should know what is that you're getting onto your hands, and that is very important to deal with your applications. Now please do not consider the get base context as this pointer of your object, and it may be confusing. Now you may feel all the 4 is nothing but at this pointer. It is absolutely wrong. Now the get base context in turn is very dynamic. When your application is running, depending on the situations and circumstances and whatever the objects that you're dealing with, and that is the address that what it is holding on to. Now holding on to that address also is very dangerous, because the component that what you're holding on to may die, or that in turn may live for a longer time. Now that in turn will not allow your application to be garbage collected, and these are the problems and these are the memory leaks that can happen. So be aware and be very careful when you're using get base context. Now the other way to find out more is go to developer.android.com and you'll get tons of information and do's and don'ts about the get base context. Now get application context. Now for an activity, the parent happens to be the application. Now the application does not follow the activity lifecycle. When the activity dies, the application will not die. So that's a safe haven for the programmers, wherein they would love to keep all the shared preferences data in your applications. Now, so because the application will not die, your variables will not die, right? So guys, please do note, you should not inflate your views. When you're at the time of inflating the views, please do not use the application context to inflate the views. Now, if you do so, now the views in turn will be held by the application forever. The views cannot be garbage collected. So that is where we call it as the memory leak, and you have to know. So this get context, get base context, get application context happens to be a very crucial part of your Android programming, and you have to take a call on it, and you have to know what exactly it is even before you use it, right? So these are the crucial stuff, and this is what it means to you. Now the storage methods in Android. Now guys, we have already checked on this. I told you about the shared preferences. That happens to be the internal storage. Shared preferences store private primitive data and key value pairs. And in fact, I already told you, I took you to the DDMS and I have shown you where the data is stored. Now, whenever you want to give the data, it is for username, give the key called as username. The value will be whatever the user types in. For the password, the key is password, the value whatever the user types in, and that is how it takes. That is how the shared preferences works with the help of the key value pair. Now, internal storage, we have already dealt. Store private data onto the device memory. Now guys, I have even showed you what exactly is the device memory in your DDMS, and that happens to be the file system, and that happens to be the secured place where you can store your data. Nobody can sneak into it because it comes under the sandbox. External storage happens to be stores public data on the shared external storage. That means onto the SD card you're storing the data. Now the SQLite database stored in the private database. It is stored in the private database, and it is also being pushed into the device memory. Like the way, the place that where you all saw the folder shared preferences, very similarly, it will create a folder called as a database, and it will store your SQLite database right there. Now, can you deploy the jar and Android? Which package is supported by it? Guys, please do remember, the jar file took its own death. That's about 2 years ago, and when we all used to work on the Eclipse. After Eclipse, we don't use the jar files anymore in Android Studio. In Android Studio, we use the dependencies, the libraries in form of dependencies. Now, no, Android does not support jar deployments. Applications are packed into Android package.apk using Android. Now, asset packaging tools and then deployed onto the Android platform. Now, guys, do remember, jar files are gone and dead long ago, but few of the applications like your Dropbox, they are still using jar files. They may ask you a question. Can you point out where Android Studio is using the jar file? Which application in Android Studio is using the jar file? Now you can easily say in the Dropbox, you have to go to the library, you have to copy the 2 jar files into it even before you compile your code. And that is where they're using the outdated stuff, and they don't consider the jar files anymore in Android Studio. So don't worry about it. Don't try to even go deeper into it. Now, what are containers? Now, containers are the object, it holds the object and widgets together depending on which specific items are needed and in what particular arrangement that is wanted. That means you would rather call the containers relative layout, constraint layouts, percentage library as same. Now, all these guys in turn will help you to call the root layout, and they in turn will help you to arrange the widgets right in that particular containers. Now containers may hold label, field, button, or even child containers as example. Now that is what it is all about, containers. If you have seen the linear layout, you all have learned how to create the child in the linear layout, right? So you can create any number of child. Inside the child you can create any number of widgets, and that is what is called as the containers. Now, can you change the name of an application after its deployment? It's a big no. We cannot change the name of the application because it comes with a package and with so many other properties. So by changing, you may have to refactor the complete project. So the answer is a big no to it. Do not do that. Now, define Android application resource files. Now, when you're creating the application in resource, we all went to layout and saw values you roughly saw, and you came back. Now, in animator, you can have all the animations in animator and anim, and all the color tables can be declared inside the color. And drawable, this is where you can have all your bitmaps, images, and all that. Mipmap, you can have various sizes of images. Now, when you're trying to implement, when you're trying to deploy your code onto tab, now you need a different size of bitmaps. Now the same application, when it has to go onto 3-inch device, the bitmap has to change into the smallest of the bitmaps. And then if you're using it on 7-inch phone, the size has to vary. If you're using it on TV, it has to vary. Now the various sizes of your button or the screen or the widgets, you're going to put it in mipmap. Depending on the device that what you use, it will map onto it by itself. Now XML, now this XML file is yet another interesting thing. Now this XML can be used in for many different reasons, and just for example, when you're writing your search application, now to define the property of search application, we have to define it in the XML file. So we have to create a folder called as XML, and we have to put everything into it. Now in layout, you know all the UIs will come in here, and in values, you know what exactly you saw. You saw the dimensions and all that, and where you can pad the screen, or we can set the values of, you know, what kind of padding you want and what kind of the padding you want on top or bottom or right or left of the screen and things like that. And menu is where you're going to bring in the menu related stuff, and raw is where you're going to create a folder. Now you can have the consolidated data like a novel, and if you want to convert that into the locale, it is a good idea to bring it in raw. Or if you want to bring in if you want to have a song to be stored, it can be stored in the raw folder and it can be used so as your asset. Now, what is the importance of the emulator in Android? In fact, we discussed about this in the beginning itself. Now, the emulator lets you play around an interface that acts as it were an actual device. Now, I told you very clearly, it is not a rectangle, it is a phone by itself. And it starts the way the phone starts, and it brings up the application, and all the characteristics is imbibed when you create an emulator that is going to be the phone. Now, for testing purpose, you can create 5 different emulators, 5 different sizes, 5 different stuff you can create, and you can test your applications on it. Now, it is the best way to test your applications by having many emulators. How are escape characters used as attribute? Guys, this is Java question. The escape character are preceded by double \\. For example, if you want to write /n, you have to write //n. For /t tab, //t, and so on, right? It is just about the double \\. Now, what is an NDK? Now, NDK happens to be a very important part of your development. This happens to be the native development kit. And in this NDK stands for the native development kit. And you normally get to write your C and C++ code, the .so library, to communicate with your kernel. And after that, it spools in the data and it gives it back to the application managers, or it gives it back to the application. And that is how it builds a bridge between the application and the kernel. Now, broadcast receivers. Now, this receivers in turn can listen to the system level events. For example, a call is coming in. The broadcast receiver knows that a call is coming in. And you're not able to handle the call, the broadcast receiver knows. Or when an SMS comes in, the broadcast receiver knows about it. Or if you're writing a healthcare device, and if it has to pump the data, if that has to broadcast the data to your application, and you'll have a broadcast receiver right in your application, and that'll be listening to the devices. Now, that is what it is. And even the second line, he says that you'll be listening to the events like incoming call, SMS, or from any of the other hardwares. That is what is your broadcast. Now, broadcast receiver helps in responding to broadcast messages from the other application or from the system. Now, as I told you, it can be a different device. Even that in turn can broadcast a message to you and a remote message, and you guys can receive it. Now, predominantly, broadcast receivers will help globally. Now, you can listen to the broadcast which has been broadcasted by any application. Now, when you broadcast, all the other application can listen to what you have been broadcasting. Now, that is where it helps, and anybody can listen to you. Now, in fact, previously I told you how many types of broadcasts are available, all that I have already mentioned. And to use the broadcast, you have to extend the broadcast receiver. Just by using this extend broadcast receiver, you're going to get an implementable function called as onReceive. Right inside this function, you guys can bring in your intent, you can check. Now here you got context and intent. Now guys, please note, this is the context that what I was talking about. Now when you're in this environment, the meaning of this context is different. So be careful. Now it's a controlled, you're inside the controlled environment. When you say context, this is not your this pointer, please do remember. And using the intent, you can check from whom I am receiving the broadcast, right? And if you don't check that, and you have to be careful, even a virus will be creeping into your application. So that it's a good practice to check where the intent, now who is sending me the broadcast, and then go ahead about it, right? So that's the best way to use the broadcast. Now, what are the security measures which has been taken in Android, and what makes the Android secure? Now, first of all of you know the Android application is a sandbox that is popularly and allow limited access to the information that is very private to the private and sensitive for the user. Now, as I told you, the sandbox information cannot be used by or seen by the other applications, by the other sandbox. So that itself is very secured. And then you can also set the permission on top of your program. And when the user is trying to use your application, they have to use the same permission to use your application, right? Now, and also you have the encryption scenario for all your messages. Now, whatever that you're trying to send between the applications, it has all been crypted. So it is very safe. You need not have to worry about it, right? So even when you're trying to send the SMS or WhatsApp or whatever it is all secured because it has all been crypted. And at the same time, the agreements, the user term, everything has been taken care of. Then apart from that, you have something called as the enterprise security that happens to be the device policies. Now, if you use this enterprise security, you can even control every variable the other application uses, because this device policies in turn is going to come in form of a wrapper on top of your application. The security application can watch at every point of time what exactly is happening in your application. Even if you want to use a variable, the super has to give, meaning the device policy has to authenticate. Only after the device policy gives a permission to you, your application will start working. And that is how the device policy has come in form of a security for the enterprise applications. And secondly, as I told you, The file system is very safe and secured, but people have hacked it. Now that shatters your thought, isn't it? And to hold onto it and to secure the file system, now the cipher, they have come up with the crypting scenario, and we can use the cipher that happens to be the third-party library, and you can crypt the complete data, what you have in the file system or your SQLite. Now, as I told you earlier about the ADB, now it's called as the Android Debug Bridge and what it stands for. Now, whatever you guys do in IDE can be dealt at the command prompt using the ADB. Now, ADB stands for Android Debug Bridge, and it's a command line tool that is used to communicate with the emulator instance. And now, in fact, I can give you some simple examples when it comes to ADB. Now, I can ask for ADB device. Note, you have the emulator 5554 device, and this is the emulator that what you're running on, and it says, hey, this is the device. And you can use the ADB port forwarding. Now watch, I can just bring in the ADB port forwarding here, and you can use the ADB port forwarding. And you can use the ADB to install package, to uninstall package, and to watch the logcat. Now I can say ADB, let me say logcat. Right now, look at this. This is all the logcat information that what you guys are able to see here. Now, if you want to, it is also possible for you to pipe the logcat information into a folder. All right, so I'll say ADB logcat. Now I can also pipe the entire thing to logcat.txt. Now everything goes right there into the logcat folder, and that is how you can pipe it. Now, like this, the ADB can be used for numerous purposes, and you can completely avoid your IDE when it comes to ADE, and everything, ADB, everything can be done via the ADB. Now, the ADB in turn will deal with the client and server, which runs on your development machine. You can invoke client from shell by using ADB command. Another ADB tools such as DDMS are also created by ADB clients. Now, as I told you, whatever you guys do in IDE, it can be invoked by the ADB commands. Now, guys, please visit your developer.android.com and you will get to see tons of ADB commands right there. And you simply copy that onto the terminal and it works the way you want. Now the server, which runs in the background process on your development mission, the server manages to communicate between the client ADB daemon and running emulator on the device. Now guys, when we practically look at Android, now Android in turn has got two different variations. One happens to be the client and server. Now server is a very thin line and it is a bridge that what it is trying to connect your hardware with the client. In between the server is running. Now whenever the server collapses, now the client also will collapse. That is when we will get to use the ADB called as a kill server, and we'll call ADB start server to bring up the server. Once if you are able to bring up the server, this in turn will recreate the bridge between the client and the hardware. And that is where the server comes into the picture, and the server in turn, ADB, that is a daemon process that is going to run on your emulator on your device. All right. So the daemon which runs, just the meaning of the daemon, which runs the background process on each emulator device instances. Right. So once the very minute the daemon dies, now even the client dies. So in between the server has to build a bridge. Now how do we pass the data from one activity to the other activity? Guys, it is very simple. We use something called as bundle. Now the bundle works in form of the key value pair. Now if we say b.putString, you want to put the data in form of put string. And this email that what you guys are seeing here, it happens to be the key, and abc@xyz.com is the value. Now this is how you put the data into the bundle. So after that, whatever the intent that you have created, that you have formed in the beginning, you're calling that intent I, you're calling put extras, and you're just trying to put the bundle into it. And that is how you're going to make the bundle as a part of the intent. After that, you're going to call start activity of intent, and that in turn will fire the other activity, and this data is sent to the other activity, and this is how the bundles can be used. Now, the orientation in Android is very simple. The landscape or the portrait. Like when you tilt the phone, the data in the phone changes the way that you make it as landscape or portrait or whatever it is. And that is what we call it as orientation. Orientation helps to represent the layout in row or column. Values are set either to horizontal or vertical. Like the way you rotate your phone, the orientation changes. Okay, it can be set using set orientation. Now the set orientation in turn will let you set the orientation dynamically. Now what database is used in Android? This is a very good question. How does it differ from client-server database management system? Now guys, you all would have looked into Oracle. Now the Oracle, the server, the definition of server is very different in Oracle. And here in Android, it is a very lightweight database which has been created by SQLite. SQLite is open source relational database, and SQLite engine is serverless. Now it has got nothing to do with the servers like the Oracle. It is serverless, transactional, and self-contained. Now it is an independent SQLite. As you all saw in your Android stack, SQLite was a part of it. Instead of typical client-server relationship of most database management system, the SQLite engine is integrally linked to the application. It has been built in to the Android. No, it is not different. It is not a third-party library. Now, library can also be called dynamic and makes use of simple function calls that reduce latency in database, right? They're trying to bring in the maximum speed into the SQLite and they're trying to get the best out of it. But just to keep you informed, Oracle is phasing out the SQLite and they're coming up with the other better database. Now, what exactly is sensor? Can you list all the 4 types that what normally we use it in sensor is what it is all about? Now, let us take a quick look. Now, when we use the sensor manager, now the sensor manager in turn will return what kind of sensors are available with your device. Now, take that sensor. The class creates an instance of a specific sensor providing method that allow you to determine its capabilities. Now, when you have a compass, what the compass can do, it gives the capability here. Or when you have the accelerometer, what it can do, it gives the capabilities here. Then we have another class called as a sensor event. Now this class provides information on sensor event by creating sensor event object. Now what it can do, because as I told you, like when it is accelerometer, what it can do, when it is compass, that what it can do, the qualities and behaviors will change. Now to that, what you guys can do is you can add the sensor event listeners. Just by adding the sensor event listeners, whenever the direction changes in compass, and it reports the sensor event listener saying that the compass is changed. And the event listener in turn will show you where exactly the north is and south is in your compass, and that is how it works. So we have various sensors available in the sensor manager, and all the sensors has the same functionality to use, and using this you'll get to know how the sensors will work. This is fairly simple. Now almost we are getting to the end of the session. What exactly is ANR? That means Android not responding. In fact, we started off discussing when we started off with threads and services. Now this in turn happens when the activity's main thread has got too much of work to perform. That is when the ANR is populated, and that is when it throws the ANR. Now to avoid the ANR, an application should perform lengthy database or networking operation in the separate threads. Now guys, I told you, even if it does in the separate thread, the choreographer in turn will start throwing an error. Now that is where we have to shift this onto the services. Now it can be passed on to the intent services. Now when it can be passed on to the intent services, I told you, this intent services is something that it takes up the job and it goes on executing the job once. If the job is executed, it stops by itself. But the other service will run forever. It will not stop unless and until you ask the service to stop. All right. So that's about it when it comes to the ANR. Now, what is AIDL? This is the Android interface definition language. Now, the AIDL in turn is going to create an interface that interface will be used by the process A and process B, so that interface will create a bridge between the process A and process B, so that you can start sending the data from one process to the other process. And that is what is your AIDL. Now, what are the data types supported by AIDL? Meaning what I can pass from one process to the other process. I can pass a string, list, map, character sequence, and then the native data types like integer, long, character, boolean, all this can be passed on to these are the data types what your ADL supports. Apart from the data type, you have a possibility that you can still pass the objects also, and this is what it is all about with the ADL. All right, guys, we have come through the entire set of questions, and almost we have covered about 50 questions for you guys. And I hope that this session was quite useful for you, quite informative for you, and this is going to come handy when you take up your examinations or when you take up your interview. Guys, do not stop here and try to gather more and try to learn more, and you'll be the best and you'll be the most wanted programmer by the corporates. As I told you that the 3 billion programmer race is on, and you're going to be the best and you're going to get the best, and if you prepare yourself with all these questions. Thank you so much for your time, and thank you for all the patience that what you had till now, and let me call it a day. Let me end this session. Hope you all have enjoyed the session, and it is going to come handy for you all. And thank you so much for everything, and take care.
I hope you enjoyed listening to this video. Please be kind enough to like it, and you can comment any of your doubts and queries, and we will reply to them at the earliest. Do look out for more videos in our playlist and subscribe to our Edureka channel to learn more. Happy learning!